Welcome to this virtual event, Embedded System in Unmanned Aerial Vehicles. I am Salvatore Dello Iacono from the University of Salerno, and today I will be your host at this event. The first speech will be held by Giovanni Di Sirio, ST Microelectronics Software Senior Engineer. First of all, we have also to thank Alan Smith for the organization of this event. The session today will be held on Microsoft Teams. We would like to remind you that all the event will be recorded and then be available online. Moreover, there is all of you can ask questions to the presenters by clicking on the reaction button and raise your hand. In this way, we will be able to give you the possibility to speak and ask a question to the presenters. But I would like now to introduce Giovanni Di Sirio. Giovanni, are you connected?
Hello, everybody. Giovanni Di Sirio speaking. Let me introduce myself first. I have been working in ST for almost 20 years now. I work into the automotive division, automotive microcontroller divisions, and the part of the ST technical staff. I also keep myself busy with open source software, and we started from that as an idea for this event. Some months ago, I was talking with Alan, the site manager here in Napoli, about a possible event regarding embedded systems. Then we decided to focus on the UAV specific event. Why UAVs? Because UAVs are the perfect example of an embedded system, basically. You have microcontroller, microprocessors, sensors, power devices, battery management, power management, communication, positioning. It is everything in there. So it is a perfect example of an embedded system. And this gave us a chance to contact people involved in open source communities working on UAVs. Who are the people that we will listen later in this event? Okay, what else to say? For ST, this is a way to like open a channel with those open source communities, and let's start talking each other. So this is what this event is about. Let's start talking about what we can do, how we can improve ourselves. And from me, this is all. So I give again. Salvatore, let's go with the rest of the event. I think I spoke even much now.
Thank you, Giovanni. Thank you so much, Giovanni. It's always fast in his speech, and this is because he wants to leave the possibility to the other speech to the other presenters to give you a better overview of what are UAVs in this moment, what are the regulations, and so on. Talking of regulation, the second presenter will be Domenico Accardo, a professor at the University of Naples, Federico II. Professor, are you connected?
Yes, thank you.
Okay,
Salvatore.
Okay, I can see you. Okay,
nice to meet you.
Nice to meet you too. I will give you the possibility to introduce yourself, and then you can start with your presentation. If there is any question, I don't know if you would like to be interrupted during your presentation or not, or if you prefer to have your question at the end.
No matter. I think there's just a problem related to time frame. So I don't know if we will go too long if we are introducing questions also. So okay. Maybe I have no problem with question, but I don't know if this agrees with the overall program.
We will try to stay in time, and if you will take too much, I will try to interrupt you and give you, to the other speaker, the possibility to stay in time, because we have many participants. We have 100 participants in this moment, but more will join later on.
I read that there was a question and answer session at the end. So
yeah, at the end there is
we will answer the question at the end.
Okay, thank you, Professor. Here you have it. You can share your presentation.
Yeah, okay. I'm sharing.
Okay.
Are you able to watch my presentation?
Yes, we are looking at your screen. Could you share your presentation by, okay. Is there any problem for the others? I don't think so. Okay, there you have it. Thank you so much.
Thank you very much. So, thank you, everybody. My name is Domenico Accardo. I'm a professor of onboard system and air traffic management and control at University of Naples and Italian Air Force Academy. Today I will introduce you the topic of drone regulation, current and future issues. And I will deal with drone regulation and standardization issues, the current regulation and the future regulation, in particular the Unmanned traffic management framework that is developing. And I will give you also some hints about the impact on embedded system of regulation, which is the topic of this workshop. So let's start from the issue related to drone regulation and standardization. We can say that drone market has been increased at an exponential rate in latest year. Also, pandemic and war had little impact, even if there was an increase in some topics, such as the use of drones for transport or for monitoring. Therefore, both the platforms, the platform manufacturers, and the service developers with drones received a strong boost. This means that the amount of drones operating will be increasing. They will going to form a sort of traffic, and traffic requires very detailed regulations to be managed, unless we can have problems in using this type of technology. I give you a small hint. This website is reporting the worldwide regulation about drones. So if you are interested about the specific regulation of a single country, you can go at this website and you can find the most important sources of information. The problem is that different countries have different regulation, and this is a sort of stop condition for the development of drones, since different regulation means also the need of different system to be installed on board. Therefore, there's a need of for international standardization about drone regulation. We are going to consider how this regulation will be included. And also we can have a specific local issue depending on the particular local conditions, such as having large desert areas, such as in Australia, or very populated areas, such as in Europe. What are the critical terms to be assessed by regulation? The physical condition of drones, energy, speed, mass, the type of operation, if daylight, if the operator shall keep in line of sight the drone or beyond the visual line of sight, what is the distance from airports or critical facilities, the need of insurance, the type of education and age of drone pilot. What is important for drone developers and for drone component manufacturer is the need for specific equipment, including the capability to have electronic or remote identification, the alternative and emergency data link, the loss of link strategy, the loss of navigation capability, the battery discharge management, contingency flight termination system, sense and avoid capability, autonomous sense and avoid for both fixed and moving obstacles. Last but not least, we need to account for public safety issues related to the risk of accidents, but also to the risk of malicious use of drones, so countermeasures against malicious use of drones. And finally, we have the topic of privacy issue to be managed. So what is reported in the next is just a summary of data in each country regarding the most important country, but you can go to this website and find more detailed information about current regulation. Let's start from US. The regulator in US is the Federal Aviation Administration. We can find an overall mass limitation for open operation. Open means operation to be carried out without a particular authorization by the Federal Aviation Administration, by authorities. Is the maximum weight is 25 kilograms, but the weight can change depending on the distance to urban areas. Also, we have a maximum altitude of 400 feet and a maximum ground speed of 87 knots. There's also a limit in visual line of sight related to the maximum distance from operator. The operator must pass an online test to be authorized, and no insurance is needed except for special operations. Then we have Europe. Europe has several categories, 3 categories for open operation, and they are related to mass limitation and proximity to urban areas. So we have an overall limit to 25 kilograms, which is equivalent to US, but we have more capabilities if the drone weighs less than 4 kilograms or 0.25 kilograms. 0.25 means not dangerous, and so you can operate even in urban area, while 4 kilograms gives you the liability to operate in proximity of urban areas. You need to operate daylight, visual line of sight, maximum altitude of 400 feet. Visual line of sight means a maximum distance of 500, sorry, this is meters, not feet from the operator. I will adjust this error. And also, we have a maximum ground speed of 68 knots. The operator must pass a test. There's a need for insurance for any commercial application, and for some application there's also the need to have an electronic tag for drone electronic identification and tracking. China is one of the countries where there's a large use of open drones. Also here we have 3 main categories. The classes are equivalent to the one of Europe. The operator in general is not required to pass a test, and no insurance is needed. There's just a security watch on operation, and in some operation electronic identification is needed. Then we have Japan. Japan has a large tradition in using drones for agricultural purposes, but in recent times is developing also operation with packet delivery. The mass limitation is similar to Europe. The main difference is the ceiling in altitude, which is 500 feet. So we have 100 feet increase in Japan. This is due to let agricultural drones to operate better. Operator must pass an online test. Insurance is needed for commercial application, and the limitation to fly in proximity of people is 330 meters. We have also India. India has several limitations in terms of security, so you need to contact police and air defense to have the permission to fly. There are several classes, and when you receive the permission, you can have also easy operation of drone if the drone is in the micro or nano category. Finally, we have Australia. Australia has large areas with desert area. Australia has a similar regulation with respect to Europe and US. The operator must pass a test for flying drones that have more than 2 kilogram weight. So for less than 2 kilogram, there's no problem. And also you can operate large drones over your land if you own a piece of land. This is the basic current condition, but you can see there are some standard conditions, but there are also differences, and we need to watch to the future if we want to integrate, such as it happened several years ago for standard air traffic. If we want to use at international level with similar equipment and operation and regulation, this type of technology. Therefore, a new type of framework is under development, that is unmanned traffic management. This is called the UTM. The unmanned traffic management study was started by the National Aerospace Security Agency in US, NASA, that has developed a study in using the drones in a free access airspace. This is for low altitude uncontrolled airspace that traditionally is known as G airspace in the terms of air traffic. And this type of regulation was considered to be automatic. So you don't have remote stations such as airport towers with a human controller inside, but you have servers that are transmitting authorization to fly. You need to fly a digital flight plan, and you will be automatically authorized, and you will be monitored while executing those flight plans. This condition is important in particular for specific missions such as packet delivery and large and extended infrastructure inspection, where you need to fly beyond the visual line of sight. So flying beyond the visual line of sight requires a network for keeping the tracking of drones and communications with the air traffic system and operator to avoid no-fly zone and to fly safely. Therefore, a series of technologies are considered for the use. We have several studies about these in the US by the Federal Aviation Administration, in Europe by Eurocontrol, in UK has a particular interest after the issues in Gatwick Airport. We have also specific use studies in Japan. I will give you a brief overview of technologies under development for UTM. This is a general concept of operation regarding the ground operator, the platform, and the flight infrastructure. Three main tasks have to be assessed that are safety, security, and equity. Equity means everybody can be authorized to access without preference of people, such as for car traffic or for trains, aircraft, and so on. So for any form of traffic. First issue is authentication. We need to recognize the drone so that we can identify malicious drones, and we can avoid that someone is stealing a drone to a legal operator to perform malicious activities. Also, an important issue is geofencing. Geofencing means automatic management of no-fly zones. For instance, prisons or airports are areas where you are forbidden in general to fly, and we need that the drones are capable to avoid those drones and to upload updated condition related to no-fly zone in case of sudden change of needs. We have important topics about the three main functions operating the drone. Communications with the remote operator, but also with the payload and with the traffic management service. Also, vehicle-to-vehicle communication can be important, not just with other drones, but for instance, also with the terrestrial system. Then we have the navigation user, and we need to have autonomous system. Many drones are operating in urban areas where you can have GPS challenged condition. Therefore, you need to have specific autonomous equipment, such as advanced MEMS inertial unit, visual cameras, air data system, and magnetometer. An important issue is integrity, which is the capability to generate alarm if the system is operating outside nominal condition, and a timely alarm. And finally, we have the surveillance function, means tracking the drones, can be cooperative using such as communication link, electronic ID, or non-cooperative using visual cameras. We have the see and avoid capability. Drones needs to perform automatic avoidance of fixed and moving obstacles. We have the management of flight termination for nominal and contingency condition, and this can be properly addressed by the use of drones. And we have important issues, other important, such as the interaction with the standard aeronautical traffic control to avoid a problem of degrading interference. A drone can enter the engine of an aircraft. We don't want this. We had the specific problems in several airports. We have a main issue. We had the main issue in Gatwick 2 years ago, and the international authorities want to avoid further problems. Also, there's a problem of interaction with the wildlife. Seagulls and other birds are operating in contrast, and we need to avoid wrong interference. Now I'm going to complete my presentation discussing the impact of drone regulation on embedded systems. There are several problems to be assessed, such as the robustness to external disturbances. So it's better to find solutions that have a graceful degradation to the drone. There are problems related to reliability, so it's important to use redundancy. Therefore, we need a compact solution and high-end components. there's a problem of integrity. We said this is the capability to timely detect anomalies. Therefore, we need components that have self-testing, self-monitoring capabilities, and also we need to perform strategy for cross-system queuing. We have connectivity problems, so we need to address the capability to operate in net-centric configuration and cost issues. Therefore, several type of technologies are important. I see all these technologies will be discussed in this workshop. Just to mention high-performance processing devices to increase autonomy, in particular, a lot of machine learning and big data management is forecast to be used in drones. We have low-cost, high-performance navigation solutions, such as high-performance MEMS inertial sensor, high accuracy and high integrity GNSS receiver. The use of fifth-generation radio modems, fifth-generation embedded solution for communication, motor control, so high-efficiency motor controllers, and finally also an important topic, since most drones are driven by batteries, and so battery discharge controllers are critical to be used on drones. So I arrived to the conclusion of this presentation. I presented the current regulation worldwide. The standardization of regulation is an important topic to push the market for both the service operators and manufacturers. UTM is an important framework developed worldwide to have this standardization and to operate the traffic of drone, not just a single drone. In UTM, autonomy, multi-sensor fusion, and several topics are very important. These topics will be related to the use of several embedded systems with specific requirements that are similar to other autonomous vehicles. Thank you very much for your attendance. I hope my presentation had your interest. Thank you, Salvatore.
Thank you so much, Professor. Just a moment, because we received a question in the chat. There is a Simone Tolotti that is asking about the European license. Open A1, A3, is it valid on United States?
No, sorry. These currently they are performing some talks to have an equivalence, but this is not valid. Anyway, we have a similar condition. There are also some restriction on the nationality of operator. Therefore, you need to have a specific test in US.
Okay. Thank you so much. You have been in time, correctly in time, but hoping that you will remain here for the open session at the end of this event.
Thank you very much.
Thank you so much. Let's give space now to the other presenters. Now it's the beginning of the new, another part of the event, the part that is related to open source communities and projects. The first speaker will be Andrew Trigger. Are you here, Andrew?
Yes, I am. Can you hear me?
Yeah, we can hear you. So I will. I have just a slide to present you. Yeah,
I will start my my presentation, and I'm hoping to be able to share my screen here.
Okay. Meanwhile, I would like to remember all the attendees that the session is recorded and will be available online in two parts. The first part related to the open source project, and the second part about the ST part. Okay.
Can you see my presentation? It should say Autopilot and ST. Yeah. You can see the presentation?
Yes.
Great.
We can see your presentation. All right. You have 20 minutes.
Thank you very much. Yes, thank you very much. So greatly appreciate being invited to come and present to ST today. So I'm the systems lead for the Autopilot project. So Autopilot runs for all sorts of different vehicles, sort of copters, planes, rovers, submarines, all sorts of different things. So this is just a few photos of the types of vehicles that Autopilot runs on to give you a bit of an idea of the breadth of vehicle types. Just one slide on sort of give you an idea of the activity in the project. We have around 6,000 commits going into our source code control system per year, so about 16 a day, about 400 people contributing to the project. We support over 100 different flight controllers and variants. We have many hundreds of thousands of vehicles around the world. In fact, it's in the millions, I'm sure, because there was one vendor that I did some work for a while that sold more than 1 million vehicles a year, and that was just one vendor. So it's actually in the millions, I think. Very much the focus is on the Shibios, RTOS, and STM32, which is why I was very interested in talking to you today. We also have an active partners program where we're an open source project, but we partner with about 100 companies worldwide that utilize Autopilot in their products. And these companies range from 1- and 2-person companies up to enormous multi-billion-dollar companies. And we work with those companies to allow them to make the best use of Autopilot that they can. And this is a photo of some of the members of the dev team at one of the meetings we had. All right, so the rest of my talk, I'm going to focus on our relationship with ST, and in particular with the STM32 microcontroller family. Rather than talking about the Autopilot project itself, we talk about, the way we're using STM32s and ways that could be better, and ways that are already really good. So most of the Autopilot flight controllers use STM32 based MCUs. So can you see my video as well? So you can sort of see a typical flight controller like that, or like that, or others like this. That's a typical flight controller running Autopilot, and each of those 3 examples I picked up have 2 STM32 microcontrollers in them. So those 3 are all H7, so H743, H757 micros, but they've also got an F103 IO microcontroller. We have 80 flight controller designs supported. I mentioned 100 before because that includes our peripheral types. So Autopilot also runs on a lot of peripherals. For example, this little tiny airspeed sensor, that runs Autopilot. That GPS runs Autopilot. Servos, ESCs, all sorts of different things. So it's not just the flight controllers themselves, but a lot of the peripherals run STM32s with Autopilot on them. There's some vehicles that have more than 20 STM32 microcontrollers in just one vehicle. So it's not just the one core micro controlling the whole vehicle. It's a much more complex arrangement than that on the bigger vehicles. And a lot of them are connected via CAN bus to get out to all the peripherals in the vehicle. We have a big focus at the moment on peripherals. We have firmware for GPSs, airspeed, compass, barometer, LiDAR, servos, ESCs, protocol adapters, lots of different things using the drone CAN protocol. It used to be known as UAV CAN. It's changed its name, and now it's under the drone CAN name. I know that ST has what they label as a UAV CAN ESC that you sell, a prototyping ESC. It'd be great if you could rebrand that under drone CAN and work with the drone CAN community to ensure you're compliant with the new standards. We support all of the above microcontrollers, sort of F4, F7, H7, plus on peripherals F1, F3, G4, L4, L4 plus coming soon. And we've got a bit of a focus to move towards CAN-FD over the next year or so. Just a shout out to whoever came up with the idea of the Nucleo boards. They are brilliant. We absolutely love the Nucleos. They're fantastic for prototyping. So I think whoever came up with the idea of the Nucleo program deserves a medal. Really appreciate the fantastic Shibios community, very, very helpful, great developer community, and that really helps us with the quite complex use we make of STM32 micros. All right, so I wanted to talk about some good, bad, and middling experiences we've had with ST over the years, And I thought I'd start with the bad. So I'd start with an example of an interaction we've had with ST that hasn't been good. And this is presented in a spirit of trying to improve things into the future. So in the early days of Autopilot flight controllers, back in the days of like the Pixar 1 and those types of flight controllers, we used ST IMUs, so gyros and accelerometers. And none of the new flight controllers use ST IMUs. And I know you still produce these IMUs, but I thought I should explain why our community, and I know many other communities, have moved away from your IMUs. And it's because you had some fairly fatal errors in them, and really, really basic. So I've just picked out one of the most basic errors in your IMU design, and this is a segment out of the data sheet for the LSM9DS1, which is still an IMU that ST sells. And if you have a look at this little bit of the data sheet, this is the chip select line, the SPI enable line. Now, just read through what it says there. It says that this is I2C SPI mode selection for the accel and gyro. When the pin is high, it's in SPI idle and I2C is enabled. When the pin is low, then SPI is enabled. That means that when we deselect SPI, that IMU is listening for I2C, but it's listening on the SPI signal lines. And just occasionally, not very often, but with you have enough vehicles with enough hours, just occasionally it misinterprets another sensor that's on the bus, SPI operations, as I2C, and it scrambles its registers. So what we get is a flight log where halfway through the flight, the IMU completely changes its scale or changes its sample rate, or so one of the registers goes crazy. And this was just an incredibly bad design decision to make the selection between SPI and I2C be the pin that enables SPI communication. I mean, that's just crazy. And yet it's persisted all of these years, despite us reporting this as being a significant problem. Now, we did interact with SPI over many years on this issue, and we got feedback. We got help from Dominique Paul Barbier from ST. We greatly appreciate that. And he gave us a workaround via some secret registers, undocumented, which are still undocumented to this day. Those registers, these secret register sequence disables I2C until you power cycle the chip. Now that seemed great, we can solve the problem, but that sequence must be the first thing you send to the chip. But if you've got two IMUs, you always do, you have the accel and the gyro, different chip selects on the same bus, it can't be the first for both. So it also has a bug. When you use this workaround, the FIFO is no longer reliable. You start getting the wrong rate of data out of the FIFO. So the workaround, in fact, makes that we still use this workaround to this day on those old boards, and we just have to turn off the FIFO, and that has significant performance impact. It means we can't sample the IMU quite as quickly as we would like to, and not as regularly as we would like to. So I thought this is the bad experience. Your IMU division really needs to up their game to have IMUs that are really workable in the real world. But let's move on to some good experiences. So good. The move to the STM32H7, absolutely brilliant. Love the H7 series. The rise, the premium boards at the time we moved to the H7 were like the F765 type boards. And it was just a breath of fresh air to use the H7. Quite tricky doing the bring up. There's some real, the different memory domains and things make it quite tricky, but we love the DMA mux. Absolutely brilliant. Finally, we're not fighting the DMA controllers all the time. We often have a lot of peripherals enabled. We might have thousands of DMA operations per second going on to a dozen or more different peripherals. And we're just running out of DMA channels. The matrix of what's available to what channel was just really quite limiting. So we absolutely love the DMA mux. Thank you for introducing that. The higher clock speed and more memory, brilliant. We really appreciate that. The 1 meg of RAM made a huge difference to autopilots, and the extra clock speed. We can now do some much more sophisticated algorithms and really greatly appreciate that extra speed and RAM. There are still some issues with the H7. it has very large flash sector size. And so the 128K uniform, whereas your previous range of chips had smaller sectors at the front of flash and then larger sectors at the back. And we took major advantage of that because on boards that don't have a separate storage device, we use flash sectors using a log-based file system approach to 2 sectors to give us persistent storage. And so on, for example, an F4 that consumes 2 16K sectors, on an F7 that consumes 2 32K sectors, on an H7 that consumes 2 128K sectors. And I just wanted to show you briefly, this is our build sizes page where we see how much free flash space we have on all of the different boards that Autopilot supports. You can see that some of this is an F4 board with, it's an F405, it only has 1 mega flash, and it's down to 48 bytes of free flash at the moment. It's getting very, very low. But even if we go to just our H7 boards, if I look in just the H7s, you can see that we're down to like 131 on a bunch of boards, kilobytes, 140, 160 on some boards. We typically are adding about 10 kilobytes worth of features a week, which means you can see that it's only going to take 13 weeks and these boards are going to be out of flash. These boards out of flash in 23 weeks. So we are getting desperately low on flash. What we have to do is start limiting features, cutting things out, not supporting as many GPS types, not supporting as many compass types, that type of thing. But we would love you to have boards that have more than 2 mega flash, 3 meg, 4 meg. Your competitors have already gone down this line. If we look at the GD32 lines, their performance lines have 3 mega flash. We think that ST should look at doing that. We know that QSPI works. We have some of our boards have QSPI external flash, and we run that, we memory map it, and we use that as additional flash. We are finding that has a quite large impact on performance, and we've yet to really master that. We're finding analyzing the performance bottlenecks in an autopilot with 1.5 or 1.8 megs of code, when we're starting to shifting code across to QSPI flash. It's really complex task with the number of threads we have and the number of priorities. It's very, very hard to analyze the performance in order to shift just the right functions into RAM to improve performance. So if you've got, if there can be any technical assistance on methodologies for doing that type of analysis to see how we change the link map to lower that performance impact, that would be great. But we actually think that bringing out future versions of the H7 series or other ones with more than 2 meg of base flash would be fantastic. That would be a lot simpler, easier for smaller footprint without the extra QSPI part. And we think it certainly make our lives a lot easier. The new premium boards are going to have QSPI flash parts on them, particularly the larger boards. So I was given one today by a vendor that has a 26 megabyte QSPI part available, which we can use. But the performance impact of that, as I said, is quite prohibitive. All right, so that was a sort of a negative experience on the IMUs, fantastic experience overall with the H7. A bit of a mixed experience, the ST microcontroller information. Because Autopilot supports so many different types of boards, we try to automate as much as possible the creation of the port to each board. We try to make it very, very easy to people to port to a new board. And we do this by building our own little databases of alternate functions and DMA maps and all that sort of thing, so that the person doing the port doesn't have to bother with those sort of details. In order to do that, we need to extract detailed information from the ST documentation that gives us things like the alternate functions and the DMA tables and that sort of information. Now, the way we've been doing it is we've got Python scripts which parse your PDFs. So it takes the ST datasheets and the tables in those ST datasheets and parses them out and then processes them in Python scripts to generate the databases that we need. And that's really a horrible way of doing things. It's really out of desperation that we did that. We know you've got a database that is in behind the Cube MX product, and that's fantastic, but it isn't at all clear to us that we're allowed to trawl through that database and grab information and put it into our open source project. So we'd love some clarification from ST on whether that's okay for us to directly trawl that database. We know it's possible. There's projects out there that do it, but we just want to, get that clarity from you that that's okay to then take that trawled information and bring it into a project under the GNU General Public License. We have used, you'll see this featured in here in CubeMX, the export pinout with alt functions. That is a move in the right direction. So that does give us a file which we can process with another Python script to produce the database we need for all functions, but there's no export DMA table in here. And so we're still using the parsing of PDFs for the DMA tables. And we'd love to work with you on a better way of making it easy to utilize the information you have in your chips about your microcontrollers. And then we'd love to also use that to validate a lot of that information that overlaps with the Shibios header files to ensure that all of the different sources of information are correct, because we frequently find inconsistencies. And what we need to do is then we actually write test code to see, is that alternate function actually working on this chip? Does this DMA channel actually work when we're getting conflicting information between different sources? And it'd be great if we could more easily extract that information in a way that is blessed by ST. All right, inconsistent naming is a bit frustrating. So the L4, for example, uses quite a different naming conventions for channels and streams than something like the F4 or H7. Alternate functions have different names on different micros. The same, USB function, the same debug ST-link functions have different names on different micros. Consistency in naming when you're dealing with so many different parts is really important. And it would be great if you could, decide on one name you're going to use in your data sheets and stick to it, rather than coming up with variants of the names. It hasn't been a major problem. We just rename things and map. It's just a minor quibble, but it would be just a nice improvement to see in the future. All right, but overall, we absolutely love your data sheets. The detailed data sheets, the app notes, absolutely fantastic. So these are just minor quibbles I've got here, really. Overall, the quality of documentation that ST produces is incredibly impressive, and we greatly appreciate it. So wish list. So what I've just got a sort of a wish list. Some of these things I've mentioned before. We'd love to see H7s and later micros with more than 2 mega flash. That would be fantastic. We're under 128K on some boards now. We'd love an open database of alternate functions and DMA maps. That would be greatly helpful. We'd love high resolution timing profiling methodologies, and maybe there's existing techniques we're just not aware of. So we'd really love some ways to get, multi-thread, complex, high resolution profiling, so we can actually work out how to make particularly good use of QSPI flash, but it's also useful for other functions as well. And so if there's somebody at ST that could give us a pointer in the right direction of how to do that, that would be great. Or if it's a new development that's needed, then that's great too. Improved fault logging. We put a lot of effort into fault logging diagnostics. We have a lot of people using the product. One of the strengths of Autopilot is we have a big user community. And so we have a logging system. We can, in the latest version, when we get a hard fault, for example, we log the entire, contents of RAM and registers, which allows us to do from the flight log after it reboots, it logs all this information. Actually, in the hard fault handler, it actually logs the information, and then we're able to then get a full backtrace in GDB and a debugger out of a flight log, which is great. But there are some situations where we can't diagnose. Sometimes we find that all of the fault registers are just 0 and we don't know what's actually happened. The bits, the reset status bits on the STM32 are very coarse-grained. They don't tell us a lot of detail about what happened. We have started using a thing called Crash Catcher recently. Many thanks to a pointer to that from Bob. And that's been fantastic. We've incorporated that into our releases, but we think there may be some more information that could be provided. And because good diagnostics, we don't get hard faults very often, but when it happens, we really want to know why it happened so we can stop it happening again. And we do have systems in place. Some vehicle types can experience a hard fault and reboot in flight and keep flying, particularly fixed wing aircraft. You could do that on a multi-rotor, but you'd have to be very high because you're going to lose like 500 or 600 feet before it could rearm itself. And a good chance you end up in the ground before that. Fixed wings are more resilient that way, they can glide. But we really want that diagnostics to be as robust as possible so that, when we have an issue, we can get to the bottom of it with a high degree of confidence. Fixing the microcontroller shortage. I'm sure that everyone here would love you to fix the microcontroller shortage, and you just get out your magic wand and make a lot more micros available. It's causing a lot of pain for Autopilot vendors at the moment. We're also getting pressure from vendors for us to support the GD32 range of micros and switch across to those because they're more readily available. We've loved the STM32s, but with the shortage, we may be forced to go down that path just because it's so hard to get the parts. What I'm doing, I'm finding I'm porting to more and more different, ST parts as they're available, and then the following week they're no longer available. We try to port to another one. Just playing catch up with what's available via the various sources. Final point I'd like to make is please stop using anti-open source licenses. The open source community should be your friend. This license here is just one of several ST anti-open source licenses. Whoever came up with that license has got truly terrible ideas of how to interact with the open source community, it's not just anti-GPL, it's anti-every license, anti-BSD, anti-Mozilla, anti-Apache. It's the poster child for anti-open source interaction. And if you can cross that off your list and no longer be that poster child, that would be fantastic. Make sure that when you do release header files and example code and things, that it is under a license that is friendly for the broad open source community. So that's about it for my wish list. So I've tried to keep this nice and short. Final slide, link to the various Autopilot community. So how to get onto our discussion server, etc. So if you want more information or want to participate in our community or contact us, one of these links should be able to help you. All right, so now hopefully I was online all that time and not just talking to myself.
No, we all hear you. Thank you so much. We really appreciate your presentation. And moreover, while you were talking, we received not only a question, but also an answer from ST Microelectronics, from Sebastian ST, that give you some answers about the, and linked you to GitHub from ST Microelectronics. You can read the comment in the chat session, but there is a question from Salvatore Marcellini, that's a PhD student, and it's studying control theory. And he's asking, he needs to change the mathematics model in the firmware, and he's asking if Autopilot is better than Pix4 for this purpose.
Oh, well, which is better? You know, it's sort of what brand of car do you like supporting? So certainly Autopilot supports, you know, research students. We've got a research channel where we encourage people to experiment. And there's a lot of people who do play around with navigation and control algorithms with Autopilot. We very much welcome people. There's experiments going on with, you know, ADRC, active disturbance rejection controllers, and new navigation controllers, and all sorts of things. So we very much welcome you. I won't try and get into the, you know, which is better game. I'm just glad that, you know, people have a broad choice of open source systems, and don't forget Paparazzi and Betaflight, and you know, there's a whole lot of other different flight controllers that are suitable for different purposes. But if you'd like to try Autopilot, you'd be most welcome in our community.
Thank you again, Andrew. Let's leave now for Gautier. The next presenter is Gautier. Gautier, are you connected?
Hello. Can you hear me?
Yeah, we can hear you.
Okay, good.
We are in time, so you can start. Are you ready with your presentation? I would just like to remember all of the participants that the presentation, the recording of this session will be available online. So what about the presentation? There was another question about the presentation. That's part of the presentation from the open source community, and I think that all the presenters will share with you the presentation on their website or GitHub repository, as they prefer. Okay, good here. If you're ready, I can.
Yes, I'm trying to share the presentation.
Okay.
Just. Okay, it starts loading. Can you see the presentation?
Just a while? Yes. Okay.
Okay. So welcome everyone. My name is Gauthier Attenberger. I'm a research assistant at INAC, which is the National French Civil Aviation University. And actually, I'm here today as one of the main developers of the Paparazzi project. So I will try to stay on time. My presentation is a bit longer than average. Okay, so some time ago, I tried to make a timeline of the existing projects, open source UAV projects, especially. So,
sorry, Gautier?
Yes.
Could you please share, because I don't think that everybody is able to see your presentation, even if I don't have any problem. Other people are complaining about the presentation.
Yeah.
Would you matter to share your screen instead?
Okay, so wait. Oh, maybe no. I have to open it here.
Yeah, also in the chat we see.
Okay, so I have to share my old screen.
Let's try sharing your screen.
Okay, can you see the presentation better now?
Yeah, it's okay for me. It's okay for everybody in the room. I think that it will be okay.
So at that point, I will not be able to see the chat, but okay.
I will advise you if there is any question. If you would like to be interrupted during the presentation, let me know.
Okay, we'll see, but maybe I hope I will be on time, so if I have questions afterwards, I can answer that.
Okay.
Okay, so as I said, I'm one of the developer of the Paparazzi UAV project, and some time ago I tried to make a short timeline of the UAV project, and this is what I found from the public information. And you can see that there is a rich history in the even looking at a few of the open source UAV projects and rich interactions. Although if there is any mistakes, I will be happy that my colleagues correct me. Okay, so where is Paparazzi here? It's at the bottom, and as you can see, this is a very old project, started in 2003. Not with many interactions with other projects, but from time to time we exchange with them. So what is Paparazzi? Of course, it's an open source UAV project, and we aim at designing software and hardware for low-cost micro UAVs. That was the leading idea when it started by two colleagues from INAC, Antoine Drouin and Pascal Brisset. So they were teaching computer science and control. It's supported by the university since 2006, and at the moment the main contributors are the ENAC, so my institutions, and the TU Delft in the Netherlands, the MAV lab. So it's a really research-oriented project at the moment, and released under mostly GPL v2. Okay, so why do we do drones at INAC? So actually we are training engineers, but also it goes from bachelor to PhD students, and we have training for air traffic controllers, technicians, and even pilots. So our job here is to do research on UAV systems. So it means systems control design, but also to participate to other scientific projects outside of the UAV fields. This is, of course, an education tool for engineers and even air traffic controllers. From time to time, we serve as experts for the civil aviation authorities here in France. And yeah, one of the key ideas at the beginning was to promote the use of civil aviation for UAVs, which is they are not commonly used, but years ago it was not as evident. Okay, so I will present the high-level architecture of Paparazzi and any UAV system, by the way. So the first thing is that UAV systems do have pilots, but they are on the ground. So the key idea is that you have a ground segment talking to an airborne segment through a communication link. In our case, the ground segment is split into many tools connected to a software bus that allows to extend the possibilities and the tools that interact with the drones. And we are also supported quite a different type of firmware and platforms like fixed-wing rotorcraft, hybrid vehicles, VTOL, and a little bit rovers as well. Okay, so if we just focus on the UAV part, mostly it's using microcontrollers, and exclusively at the moment the STM32 line with the F1, F4, F7, not yet the H7, but that looks interesting, of course. And sometimes a few CPU, mostly ARM, embedded ARM, when it comes to power drones, for instance. And of course, all the low-level peripherals. On top of that, the legacy boards were using directly the bare metal implementation based on the lib OpenCM3, but all the recent boards are either using RTOS, ShiBOS as an RTOS, or directly Linux on the CPU type. On top of that, we have our API that provides some general services for exchanging internal message, external messages, provide state interface, access to peripheral, and so on. And on top of that, of course, you have the user level with the autopilot task and when requires separated low level fly-by-wire, which is just connecting the radio control to the actuators or listening to the autopilot's instructions. Okay, so the next step is to look at what is inside the autopilot, of course. And flying with an autopilot is not something that difficult in the end. You just need to get sensor data to fuse them into estimation filters. They are called INS for Inertial Navigation System, or AHRS for Attitude and Heading Reference System. Then you have to push the results somewhere to the control stack that does the navigation, guidance, and stabilization. And at the end, you have the actuators set points that you send here to the physical output through the different drivers. So that's the general idea, but you need to connect all of that together. And it's nice to provide some tools to make this easy and not too tightly coupled so that you can exchange components easily. So for instance, we have internal software bus to exchange sensor data from sensors to estimators. We have the blackboard type state interface to publish the current status of the aircraft. We have the dispatcher that handles the different modes and the different control stack. And some other services like the communication or data logging. And finally, because, well, flying for flying is nice, but sometimes you have to do something. So you also want to control the payload and to have it connected to the rest of the system, to have access to the state of the aircraft, access to the sensors, publish data, and so on. And the last thing is that you want to make it configurable. At least for Paparazzi, we would like to make it as configurable as possible. So we are using a lot of XML files to describe the different components in the airframe, to describe the autopilot, to describe the different modules, the flight plan, and so on. So again, the key idea in Paparazzi, and that's a little bit different from the approach of other projects that are providing kind of binaries. Of course, you can adapt it to your needs, but they provide the binaries for every board, and you can just run with that. In the case of Paparazzi, we want to keep it as modular and flexible as possible. And every time we change things, we use a lot of code generation. And finally, we recompile the firmware every time and flash it for every flight, every time you change some configuration elements. So the different flight modes that you can find, and that's also something very common in every project. You have different ways to interact that can be at the very low level, attitude, rights, velocity, position, more high level flight plans, and so on. So what is possible in Paparazzi? Of course, we do have the direct control from radio control. We have the guided mode, which is very similar to the one that you can find for Autopilot or Pixar, and that's use the board, the flight controller board, as like a stabilization board, and you just send position and velocity. What we call the mission mode is actually the normal way to use many of the other projects. So you just send a bunch of lines, segments, circles, and actions. And we have something very specific to Paparazzi, which is a flight plan language to describe. That's a full programming language that is used to generate codes and a complex state machine. So just to give you a short idea of what you can do with that. So from the description of the XML file that describes the flight plan, basically we have a list of waypoints, so a fixed number of waypoints, and a list of blocks. And this blocks, it describes sequence of actions, and you have a bunch of standard navigation patterns like go to a point, follow a line, do a circle, and so on. But you can also use for while loops exceptions, so like conditions, the routes, which should be the same as a go-to instruction. And you can also call any function. So you can actually program almost anything you want in C and have it available as a navigation function in your Autopilot. So finally, this is generating code, which is finally compiled and flashed to the Autopilot. And the user, as an operator, can move the waypoints, jump to different blocks, and change settings. So in practice, this is a very short example to show you. So here you have a block that describes a spiral, which is stupidly complex, where the altitude is changing with the index of the for loop here. The radius is increasing with the time spent in the block, and it goes for 60 seconds. And you have some conditions to leave this block on the data link loss or power voltage going lower than 10 volts in this case. If you generate this, it gives you this state machine here. And actually, if you look at what a human operator should do to do the same, that's extremely complex. That's almost not possible. You have many variables, many parameters to change in continuous time, and you have to select the correct next block. So that's not something that you can do by hand, let's say, and but it's actually very easy to describe in a programming language here. Just to tell that it exists, you can also use the Autopilot as any other Autopilot. So just send a sequence of actions like go to circle lines or any custom patterns or actions that you have registered to the system, and you can do many things here in a more classical way, like a waiting queue of actions. The next interesting feature is to deal with the different Autopilot modes. And when we do research, we like to change what the Autopilot does every time, the different control stacks, and even change the experiments different ways to handle interaction between modes. So the legacy code has the two firmware for fixed wing and rotorcraft, with one very tightly built and very hard to change. The rotorcraft firmware, which is much more flexible, and that ended up with way too many stupid combinations of modes. And finally, we came with a generation of Autopilot mods. So the idea is that you can describe in an XML file the logic of the modes. So in this short example, you have manual modes, the home mode, and fail-safe mode, and the navigation mode. So the 4 dots. You have some conditions to select a mode, to leave it if you lose the RC or if you go too far. And finally, this state machine is generating C code that is replacing the static Autopilot logic in the legacy code. So you can be very flexible and have as many modes as you want, and you can change the flight stack according to your needs if you want to do some flight control studies. Okay, to continue, I will show you some applications and research that we have done with Paparazzi. Well, the first thing is that we have changed the way we are working. So before, when we had a new concept for, here in this example, it's for aerodynamic design. So we have a new design, and to go from the idea to the maiden flight, we used to have 1 year of development. And now, because we can also use modular design, and we can use 3D printing techniques. We can do the same thing, but in 1 month and with more complex shapes. So this has really changed the way we are working. And that also explains why we need some flexibility in the software behind to control very different platforms like VTOL. And speaking of hardware, of course, that's necessary to make it fly. Most of the aircrafts are just unstable. They couldn't fly without a flight controller. And I don't know if you can still see my video, but that's the latest board that we have designed and produced at INAC. So it's called Tawaki. It's based on the F7, and as you can see, we have many connectors to be able to connect different kind of sensor and actuators. But we are also designing our own sensors. So that's sensors used for meteorological studies with pressure, temperature, and humidity. This one has no MCU, but sometimes we also design sensor with their own processing capabilities. And in this case, this is a 3D wind prim and turbulence probe. And as you can see, it has STM32F7 also processor to get data from the differential pressure sensors and pre-process also the data, record at high frequency and so on. And of course, exchange data with the flight controller board. This is another example of a large scientific project aiming at studying the evolution of cumulus-type clouds. So the idea is that we want to probe clouds with several UAVs if possible. And for that, we have designed, and you have the link if you want to have the scientific publication around that. We have designed adaptive patterns. So the aircrafts were carrying their own sensor for measuring the liquid water content and the physical properties of the clouds, but also to tell us if we are inside or outside the clouds in real time, that you can see in the plots below. And based on this input signal, we have designed a flight strategy to follow the borders. And all of this is included inside the flight controller. There is no ground control for the immediate trajectory. There is no external CPU board to perform the high-level navigation. Everything is done in the flight controller. And we had the chance to participate to an international flight campaign at the Barbados Islands in January 20. So here you have an example of two aircrafts. So we are taking off from the lands close to the seashore. Then we go like 10 kilometers away above the sea, waiting for the clouds. And when an aircraft finds the clouds, we start the tracking, and you can see that in this flight, two aircraft have been able to automatically follow the clouds for around 20 to 30 minutes. So for instance, on the left, you have the ground trajectory. And if you compensate for the winds moving the clouds, you can see that in the reference frame of the clouds, the aircraft is actually turning around it, going in and out, the blue being out and the pink being inside. So that was a rather long campaign with 3 weeks and well, many flights with 1 or 2 UAVs at the same time. We have also the chance to have Hmi Laboratory. One of the laboratory or research group at INAC is studying Hmi for aeronautics. So we have worked with them many times to try to improve the way information are displayed. And there are a lot of information to display, but if you just give too much information to the operator, it might be very lost. So that was the very first version of the Hmi of Paparazzi. And we have tried many things, like funny things. That was the project students. We also have tried to make an Android version of the interface. This was conceptual design with students with paperboards to try to see what's important and so on. We tried a web version some years ago. This one was the result of research projects using novel libraries for interactions. We tried some very stupid things. That was really for fun. And finally, the one that we have been using for 15 years was still the best until we have reached the end of life of GTK2. So we have a brand new GCS, which is still under development, but that is quite working very nicely, and it's based on Qt and C++. But finding the proper way to display information is really a big headache. Okay, so what will be the future challenges for drones? In my opinion, we have to find the right balance between many aspects. The first one being safety, and we have to clarify what is being certified and what is acceptable to make UAV flying in a safe condition. We need to be able to operate them within the airspace. And of course, we have seen the first presentation. We have initiatives from the US with the UTM system, with European U-Space, and same thing in other countries. We probably need some markets to support the drone activity and to provide cheap or affordable hardware. We should, of course, consider the social benefits. Shall we use the drones to provide medicine in remote areas, to study the climate change, or to provide better education to engineers? Or, well, we know that there are some other less friendly applications to drones. And finally, the social acceptance. We have many big companies plans to use drones to make a delivery package or to make urban air transportation with air taxis. But okay, are people ready to have that many drones flying over their heads in urban areas? So that's a question. So for open source projects, of course, many will focus on leisure or commercial solutions, and that's a good thing, and probably Paparazzi is not one of them. We are really focusing on research and education at the moment, because, well, we need to understand UAVs to explain it and to teach that to the students. And we also need to customize the products and the solutions to participate to different types of research projects. A big challenge for this kind of approach is to comply with the very highly moving regulation, and we want to keep flying, but in a safe conditions. And of course, keep exploring new research ideas, not only search and rescue. And finally, yeah, open source projects, they live with their community. So of course, we are all welcome to join Paparazzi or any other projects. And we do have some questions from ST, and most of them have been already raised by Andrew just before. So we struggle sometimes with the DMA channel. And the good question from the previous presentation say, are we allowed to use the XML file from CubeMX? So we have to check with the information provided in the open source files if they are enough for what we have to do or not. Again, some requests regarding the DMA. So I'm not the specialist of the very low level, but my colleagues here will be happy to details or answer questions or so on. Yeah, the hardware shortage, that's a big issue for everyone, I guess. So do we have plans to have access to MCU samples, at least, to design new components, new sensors, new autopilot boards, etc. And finally, some other product lines are offering customized peripheral like PIO, programmable input and outputs. That would be very convenient, and is this something which is planned? So, well, a few questions for ST.
Thank you, Gauthier.
Thank you very much.
Thank you so much to be here with us. For now, there is no question for you inside the chat, but we hope that you will remain connected until the end of this event, because there will be an open session with for questions. Okay, let's move on with, thank you again, Gauthier. Let's move on with Bob Anderson for another open source project, Pecan. Bob, are you connected? Bob? Meanwhile, there is a question for Gauthier. Do you support the MAV link? While Gauthier, are you still connected? Yeah, there is a question in the chat.
I don't know if you still hear me or not, actually.
Yeah.
Okay, sorry.
Do you support the MAV link?
So the MAV link. Yes and no. We do have some modules connecting the Mavlink and Paparazzi. The main issue is that the concept of operation of Paparazzi, which is mostly the flight plan, is very incompatible with the tools using Mavlink. So you could display the position of the drone, but you would not be able to interact with it. So that's quite limited. We do also have some connectors for ROS1, and we are working for the ROS2, but that's not something people within the community are using a lot. So again, the interactions are quite limited. But it's not impossible.
Thank you. There will be space for more questions at the end of the event. Bob,
yes,
now we can see your camera.
Okay. Yes. Okay, so this is a little bit of a deviation from the presentations about vehicles with defined missions. We're very much involved with balloon flights, which the balloons tend to make their own mission according to the atmospheric conditions. So we can get some predictions, but what's this about? So the Pecan project is about tracking balloon flights of all sorts of types. That can include the normal weather balloons that everybody I think is fairly familiar with, made out of latex, or high pressure balloons, which are more intended to go on longer missions, or even some specialist balloons. One team in Germany basically puts together a solar balloon, which is a balloon made out of parachute material with clear and dark panels, and it heats up in the sun and rises up to about 1,500 meters. The goals really are just learning and experiment with radio links, power controls, all the things that the drone community does, but we do it on a different scale and with different objectives. And their links are really associated, getting our data back from a flight is really associated with the amateur radio system worldwide. So we're a bunch of experimenters, and there are lots and lots of people involved in actually doing these amateur launches and tracking. Okay, next slide, please. All right, so there are lots of balloons go up every week, and I think that ST would be more than familiar with Vaisala, the company that puts up the radiosondes, or that provides the radiosondes that go up out of all sorts of meteorological departments worldwide every week. I think that's got an F100 in it, so I'm not sure who the salesperson is who got that contract, but they must be very happy, or it ran out a while ago, I don't know. But these devices go up. They go to up to high altitudes where the latex balloon eventually bursts at 30 or 40,000 meters, and the whole thing just falls back down to Earth. Of course, it's providing all sorts of information on the way up. Okay, next slide, please. Now, amateur radio operators just hate to miss out on fun, so there's been an involvement in ballooning for amateurs for quite a long time. As we talked about, there's pressure balloons, and there have been some flights that have been launched who have done 3 circumnavigations of the planet. Particular guy in Australia did that and made the news. There's the weather balloons for the short duration flight, which is normally a case of just getting up there, waiting for it to burst, getting the data as it goes up, getting the data as it travels, and then tracking it to the other end. Tracking is used for in-flight and for recovery. So unlike the radio sonde, radio amateurs just hate to lose equipment. So what we really normally have is the system reporting in through our network of packet reporting system, and that's called APRS. The system was invented by a US radio amateur many years ago and has been deployed around the world now with radio gateways, which basically talk into the internet and provide packet information to that network, so people can get information in and out. A lot of that information can be position information as well as telemetry data. We even send slow speed images over it, and that gives us an ability to track a mission in flight, whether it be a short one or whether it be a long one. These things will pop up in Japan, and then, you know, these pressure balloons will pop up in Japan or over China or over Europe, and they appear in the APRS network. There are also other methods for doing this. There's another system called the weak signal propagation reporting, which is designed to basically provide position information from stations, and really for measuring propagation, generally on high frequency, whereas APRS is more focused on the very high frequency band, the 150, 140 megahertz band. But we have this nice infrastructure that's been developed over years for being able to track these flights. So next slide, please. All right, now this is quite a active community, and whilst it's not thousands per week going up, here's a snapshot from a extract out of the APRS network. It's called it's at tracker.habhub.org, and it's going to show you on the left-hand side which flights are up at the moment and give you a graphic view of those flights and the tracking for it. The tracker site here attempts to make predictions about what's going to happen with the flight. You basically can put in a flight plan, a prediction, and when your flight launches, because it's known to be a type balloon, then it'll appear on the habhub.org website and you can just watch it. You can also add the fact that you're a chase vehicle, that you're going to go and recover this balloon, and you'll get tracked as well, so that you can see the progress of what happens. I'll give you a list of all these websites at the end, so that for those who are interested can go find out about that. Okay, next slide, please. Also connected into the APRS network are several websites that basically plot independently the movement of, in this case, a balloon, but it could be a vehicle or whatever. This is a flight that went up over the weekend, last Saturday, and you can see the track has been reported here. This is aprs.fi, site that's been run for a long time, and you will see what happens, and there's going to be track points, little red dots you'll see there. We'll put the cursor over that and it'll show you which particular ground station received that position report from that particular flight at the different points. And it'll go in through all different locations depending on who has a gateway into the internet, or it may go through a relay station to get to another gateway. But this is the part of the whole project here is what to do with tracking and tracing. Okay, next slide, please. We also, for the Pecan project, just to focus a little bit on what we're doing there, have put together our own dashboard. So that flight that you saw that was up on the weekend, here's some of the telemetry data that we pull out of the APRS network to monitor the health and the safety of the equipment, what's going on with battery charging. So you can see there that this is a particular tracker. It's got an ID. It's the type it is. It's a type 10B, which is one of our older trackers. When it went up, what's going on with the number of beacon messages it's sending, image messages it's sending, which in this case it's not sending any images. You can see the charging system. This one's got a solar charge system, and it's got lipos, and you can see the power management of what's going on there. There's a little bit of a setup problem with this one. 0 milliwatts isn't the right power consumption, but so be it. We also have air sensors on board. So there's BME 280, which is measuring the air pressure, temperature, and humidity. We can support 2, only 1 is equipped at that time, and other subsystems basically report errors. And down below in this particular graph, we can see there's going to be a marching display which marches through, showing when we had a GPS lock, whether it was valid, what packets were sent. There's graphs that extend off the screen here that show the battery volts and the power consumption, etc., etc. The temperatures of the transceiver, the temperature of the radio, temperature of the STM32, all gets displayed for us on our dashboard, so we can monitor a flight. Next slide, please. Now, trackers. Well, amateurs being what they are, your normal approach when you get started in this area is to grab a bunch of stuff and put it together. So you get a foam box, you get some common parts like a handheld transceiver, you get a GPS module, you get perhaps some environmental measurement or some altitude measurement, other altitude measurement. You put it all together, you figure it out, you assemble it, you test it, and you're ready. You put the lid on and you've got a nice big box ready to launch on a weather balloon. This is normally the path that most people take, and this is where the guy that basically originated the Pecan project started as well, with some of these types of endeavors. Now, this is not particularly elegant, but it gets the job done, and it allows you to fly something, get some tracking data, and get some experience in flying weather balloons and getting a result and tracking it when it gets to the other end. Now, next slide, please. The Pecan team is actually a small group. Its original founder was Thomas out of Germany. Sven was an early joiner with the team and helped Thomas with going from the foam box and some earlier less elegant designs into some more integrated single board designs. I sort of hooked up with those guys after I got interested in high altitude ballooning, and I'm sort of the software hacker on the team now, primarily designing around running on Chibios and making the whole thing multitask, multi-process, so that we can run GPS at the same time as transceivers, at the same time as everything else. So this is the team. Next slide, please. So we've gone from the styrofoam box model to devices like this. This is the latest variant of the tracker that we're working on. It has STM32 at the heart, L4 P5. You can see all the pieces that go on in there. We basically have everything we need to be able to put a long-term mission up with this, because we've got solar charge. So if we want to run solar charge and LiPo, or solar charge and a supercap, we can do that. We can measure with all the environment sensors, and we tried to go for obviously optimizing power supply here. So it does use the L4P5 with the SMPS V-Core supply, and we've got SPI flash on there so that we can write all our flight data into the flash, as well as in fact keep track of all the image data that's been sent as well. The camera on the left is an OV5640, and that's supported through the DCMI interface of the STM32. It's fully concurrent in operation, and it's running Chibios. We actually run with the Chibios latest version, always on the bleeding edge with Giovanni to catch the latest features and bugs. It's really good. Okay, next version. Next slide, please. Hello, next, there we go, good. Now, sometimes you want to go for not the full featured version, and sometimes there's competitions like that. I think there's competitions in Poland for the lightest and longest flying tracker. So then normally you will do that on a super lightweight version like this. This is what we call the Pecan Femto, and this one is designed purely to get the weight to an absolute minimum and try and win a competition for staying afloat and alive over the longest distance. We trim it right down. It obviously has to have the solar circuit, and we like to have the environmental sensor, and normally these are transmit-only devices. So you can see that there can be multiple different devices here. And in fact, the Pecan series there's quite a few boards involved in this. At the end, you can get to Thomas's website. I think I've given his WordPress site at the end. You can go and see some of the ones that have been developed over the years. All right, next one. All right, so just to give you an idea, now we're not talking about high resolution or high quality images here, but this is not bad for a $5 OV5640 camera. This is just an image taken. We're downwards facing, and of course the majority of what you get is going to be cloud once you get up to a certain altitude, but every now and again we get a good shot, and here's one taken over, I think this is over Berlin, this one. Okay, next slide, please. And then there's the recovery. Well, recovery, normally we like it to come down in a field or somewhere good, but it's not always easy. Sometimes you get stuck in trees. So normally the recovery vehicle is equipped with long pieces of conduit, saws, ladders, or other devices to hook these things down out of the cloud, out of the foliage once when you get stuck up there. Normally, I think this is probably one of the more awkward landings. Other times in Australia, we're generally lucky. We fly in areas where it's going to come down in a farmer's field, and you get to the farmer, and the farmer will often come and help you find the thing out in the fields. So the thing we do with this sort of stuff is when we're on the ground, then we'll run what's called a fox hunt beacon. And if you're familiar with amateur radio at all, you'll know that fox hunting is a direction finding technique, normally to locate where a transmitter is, and we'll do exactly the same thing here in the tracker. When it's on the ground, it'll switch into fox hunt mode and send out a lot of beacons for us to track down and locate the particular box on the ground or up in a tree by radio direction finding. Okay, next slide, please. All right, well, that's pretty much covered it. What I was trying to do here is not a lot of technicality in this. It's really just to introduce you to the concept of an unmanned vehicle, over which we have not a whole lot of control. And for your reference there, you can go look at the HabHub org site, aprs.fi, which is a site connected to APRS, aprs.org, which will give you some information about what that is. Unfortunately, we lost the original developer just in February, so he's no longer with us. APRSIS, which talks about the internet connection, and you can go to Thomas's WordPress site to see some of the previous developments of the Pecan product, or Pecan project, sorry. All right, that's it from me. Thanks very much.
Thank you. Thank you so much. We really appreciate your presentation. We are also in time. We are sorry for the problems with the sharing of your presentation. Thank you again. For now, there is no question in the chat, but we hope that a question will come at the end of the session. Thank you, Bob. The next presenter will be Ramon Roche. Ramon, are you connected? Sí. Okay, we can see you.
Hola,
Ramon.
can you hear me?
Yeah, we can see, we can hear you. Could you share your presentation, please, so we can start? Because...
Yes, definitely. Do you think it's best if I share the file? I don't know if any.
No, probably it's better if you share the screen like we did before.
Yes, let me try and do that right now. 1 second.
Meanwhile, Ramon is the general manager at Drone Code Foundation. You are perfectly in time. Okay, on time.
Can you see my screen now?
Yes, just a while that it's coming. Oh, we cannot still see your presentation. Probably you have some issue with your connection because I see your camera a little bit bad. Does anybody can see the presentation? No, we still see a black screen. Okay, we will share the presentation.
Let me see if I can turn off my video.
Yeah,
it helps.
Okay, now we can see your presentation.
Can you see my screen now?
Yeah, we can see your screen now. Okay, let's
Excellent.
move on.
Right.
Thank you.
So try this without my video. Okay, with you.
Okay, you have 20 minutes. If there is any question.
All right, thank you. Well, thanking for inviting me. All right, thank you. Well, like I said, I wanted to begin for inviting me to you today and for my stage with meeting. Today, I'm going to be speaking to you over, and I'll try to do a good job at running through my slides. Let me know if there's anything that's not clear, and I'll try to stick around to the session Q&A session towards the end. Quickly about me, the program general manager. I think this slide is updating for Drone Foundation. I'm not going to go into too much detail. I'm going to share a link to my presentation so that everyone can read on my profile. I want to start by talking about the impact of open technology in the economy. I think this is something that it was briefly mentioned at the beginning of the presentations, and this is something that I think it bears repeating. And I think that is a great example that if I bring up this report that by the European Commission that got published in 2018, and it basically says that open source is helping the economy, is helping companies, and is helping governments. Reducing vendor lock-in and reducing the cost of ownership. But most importantly, it goes into detail into mentioning how investing into open source contributions actually has an impact into the GDP of the European so link to the report in my presentation so that you can download that. So let's talk about open source drones. For those of you that are not aware, the Ps4 ecosystem is basically revolving around Ps4. There's the Mapping project, that's the protocol for communication for drones. We got Pixar Project, which is open source, open hardware and open standards. We also have the Q ground control drone station and Mc Sdk. But at the center of this, we got the Ps4 Autopilot, which I'm going to be speaking of now. We call it the Linux kernel of drones. It's an autopilot with really modern architecture. We are running on top of the Apache Nautilus RTOS. We have published and subscribed middleware called UORP, and most importantly, we have a runtime parameter system. And like I mentioned, we have a mapping interface who support lots of different vehicle types, multicopters, fixed-wing VTOL, submarines, boats, and rovers. The Ps4 Autopilot has lots of benefits when trying to implement it. And the most important that I think that we should be mentioning is that we don't try to be a finished product out of the box. We like to mention that we are like a 90% solution where we expect companies to come in and actually put in the remaining 10% to cater to their whatever market vertical they're trying to capture. And this is how we represent that. We have a Ps4 stack, which is growing over time, and then companies build products on top of the Ps4 stack, and they add their differentiators, which could be different things like a user experience. Maybe they certify their crafts, they have different features, just customize them. And that's how companies are typically using Ps4 right now. I will have lots of examples towards the end. Just quickly before going into the next topics, I want to mention that we are a BSD3 licensed open source project. We have more than 1,000 active contributors through all the different projects. And right now, I think more than 99% of the hardware that we're supporting is ARM-based. And there's lots of different ways to get in touch with the developer community and then the maintainers. We have a weekly call on Wednesdays that everyone's encouraged to join. We have forums, and we have a Slack where you can join and reach out to all the different groups that we have in there. All of the resources can be found on their website. We have lots of different contributors, like I mentioned. And I want to quickly jump into the next project because I have a lot of things to say about this and then the subsequent slides. So we have PIXOC, so the open hardware and open standards. And I really want to mention about PIXOC is that there's a lot of different PIXOCs flying out there right now. We estimate there's around 1 million PIXOC right now in the air. I think another presenter mentioned something about 1 million vehicles out there, and I really think that's true because there's a lot of drones out there right now. And the PIXOC project is the open hardware project for drones. It was initially created by Dr. Lawrence Mayer. We got a quick drone here. This is a Pixar-4. This is a flight controller for those of you that are not that familiar with PIXOCs. It got created by Dr. Lawrence Mayer, like I mentioned. Picture here, we got the PXIMU, which is the first iteration of the PIXOCs. It got introduced in the DIY drones blog. It turned from a research platform to an open hardware project. There's been lots of different PIXOC hardware over time. I picture here some of them, not all of them. And most importantly, I want to talk to you about the current generation of PIXOC. So right now we have 2 generations, the Fmu B6x and the Fmu 6x. The Fmu B6x is an XTM32F7 based flight controller. Has very modern architecture, secure authentication, has Ethernet, has 3 redundant domains, completely isolated sensor domains with separate buses and separate power control. It allows for parallel and continuous operation, even in the event of hardware failure. There's links in here to look at the open standards, so you can actually download and see diagrams in full. And I know that you might not be able to appreciate them through these slides. Now we also have the Fmu B6x, which is an H7 variant of the 5X, which has a similar architecture. And most importantly, the newest thing on this new PIXOC is that it's a modular design where we have the IMU, the Fmu, and the baseboards, and there are different components. And we are working with different manufacturers to guarantee that different components are going to be cross-compatible across different manufacturers. Also, one thing that I would like to mention here is that we have the PIXOC Autopilot bus, the PIXOC connectors, which are also standards, which are being used in the current generation of the flight controllers. And they're all part of the family of open standards that we've been publishing. You can find them in GitHub right now on the PIXOC/PIXOC standards. And they're really opening the door for the community to start developing hardware. Historically, PICSOC has always been like, there's one generation of PICSOCs, and then the standard is out, the hardware is out, and then there's vendors that implement them. And there's usually one vendor that implements this hardware, but now we're moving into more of a community-based approach where we're going to publish the standards, and we're hoping that many manufacturers pick them up. Right now, that's already the case. I can show you an example, like the out there in SkyNote is an Fmu B6x standard based on the DSO11 open standard, and then the Holybro PICSOC 5X is also available, which is also based on the Fmu B6x standard. We worked with a company called Comstix, owned by Altium, on releasing the Fmu 6U standard, which is a variant of the Fmu B6x, which is more of a moving away from the modular design to a single PCB-based design. And characteristic on this one is that it also has a Raspberry Pi CN4 with it. Talking about hardware and autopilots and software, and I mentioned about the industry. So how do you get all those open source projects to be adopted by the industry? And this is where the Drone Code Foundation comes in. It was founded in 2014. We're trying to follow the steps of Linux kernel. Actually, it's hosted within the Linux Foundation. It's a nonprofit organization, and we're home to some of the projects that I talked to you on the first slides, and I'll show you in the next one. And we host the projects, and not only the projects, but the communities, which is something that I think one of the previous speakers was mentioning. Open source, it's great, but it doesn't just happen alone. It's just not just one person doing this. There's a huge community of developers. There's a huge community of companies that work with the developers to make this happen. And we're sort of trying to encapsulate this within the Drone Code Foundation. And we're home of the Ps4 and PICSOC ecosystem. And the ecosystem is really revolving, like I said, in the Ps4, around the Ps4 Autopilot. We have the industry standards, the hardware standards. There's third-party projects like ROS, which is really deeply integrated into Ps4, the industry association like Drone Code, and any other that we can partner with, and the open source projects. And it's just the life cycle of the foundation. What does the foundation do? We help with leadership, coordination, marketing, securities. We put certification frameworks, legal support, training, and global community events. We actually have a global community event coming up soon, the Ps4 Developer Summit in June 23rd and 24th in Austin. I encourage everyone to join us. It's going to be the 4th edition of our event. We're expecting lots of open source drone developers to join us. So if you're interested in learning more about drones and open source and robotics in general, please join us. Going a little bit back to the Drone Code Foundation, like I said, we help with governance, membership, development process, infrastructure, ecosystem development, and IP management. I'm not going to go into each one of those, but I really wanted to mention that we are helping put PX4 and all the different open source projects around the PS4 ecosystem into the different verticals of the drone industry, and we're getting a lot of adoption from industry organizations. These are some of the supporting members of the Drone Code Foundation. And what do those members do with the foundation? It's one thing to come in and support the open source projects, but we also want their feedback. We also want their participation. So one of the things that we're doing with them is participating in work groups and special interest groups. I think I already mentioned about PICSOC. The PICSOC Special Interest Group, which created in 2020, is actually the one that is creating the open standards like Fmu B6x, which is the new generation of PICSOC. So we have different work groups like the Flight Management Unit work group, in which we are creating the open standards and looking forward to different components that are critical to the flight controllers. But we're also moving away from the flight controllers. We have the Payload work group and the BMS and the Radio Interface work group. There's a lot of different open standards have been already published. Like I said, everything is published on GitHub. I posted another link in this slide. The Payload interface standard is something that is, we think, really helpful, and it's been already implemented by some of our members. It's defining the mechanical, electronic, and software interface to be able to plug and play different types of payloads. In this case, the manufacturer created a gimbal, and they're able to plug in that gimbal into any Ps4 system and different sensors into their gimbal using these same interfaces. In the future, a specific vendor is going to be able to have plug and play compatibility with the same gimbal between different drones that they sell. But the actual goal of this payload standard is to be able to plug and play between different vendors, even not just within the same vendor in different products. Different open standard. We also care about batteries. I think another even speaker was mentioning the importance of the battery systems. This is a work in progress work group, and we're trying to define what the smart battery system should be. Connectors, software, and there's a different companies that are interested in building this. This is one of the examples of one early implementation of the standard that we've been creating. Lastly, I wanted to mention some of the examples of Ps4 and the open source projects around the Ps4 ecosystem are. I have different companies building different vehicles. There's not just multicopters, like I mentioned, it's fixed wing, it's vertical takeoff and landing, and they're doing deliveries, they're doing different things. I have lots of different pictures in here, which I'm going to quickly scroll through, just to give you an idea of the different applications of being used by companies using Ps4. And I know we're running out of time. So lastly, I want to mention that this industry, even though it's been a couple years already, the industry is just getting started. And it's being powered by open technologies. So I want to leave you with this slide, and it's an opportunity because right now the current value of the drone industry is set around $27.4 billion, and it's estimated it's going to be around by 2026 by 58.4 billion. And if you took into consideration the first slide on the report that I was talking to you about, where if the number of contributions grow in open source projects, it's going to have an impact into the economy. The same applies to the drone industry. If there's more contributions to open source projects, not just Ps4, call it Paparazzi, maybe, and also Autopilot and all the other different open source projects that are very well in line with good communities. If there's more contributions to all of those projects, the drone industry will grow and will grow together, and there will be more opportunities for everyone. Well, and that's everything for me. Can you see me now?
Salvatore, you are mute.
Oh, sorry. Thank you so much, Ramon. You still have a few minutes if you would like to add something. There is no chat. There is no question in the chat. The next part will be Ramon. Can you hear me?
Yeah, I am here.
Yeah. Okay. Thank you so much. Now we will move on with the next part of the event, with a more in-depth presentation of the hardware components related to the UAV. We have the first presenter will be Adriano Basile, that will introduce the topic. Oh, okay, I can see you, Adriano and Antonio Cirone. Thank you so much to join us. Okay, we can see you. Okay.
So really,
Adriano.
Yes, I'm going to share. Do you see my screen?
Yes, just a while. Okay.
Okay. Perfect. So only to introduce my colleague and in general what ST can offer for drone. I seen the microcontroller on several presentations before this one. Clearly, as a ST portfolio, we have really a wide portfolio that could fit the drone application. I would also introduce one disclaimer for me and for the colleague that will present after me, that we are talking about products that are classified as standard products. So this means that these products are not qualified for safety critical application and aeronautic or aerospace application. So these to be to provide you this disclaimer. We considering the short time that we have, we will see in after then this block diagram, global block diagram. I will introduce Antonio that will talk about the sensor that ST could provide for drone. Antonio is a marketing manager for sensor connectivity and analog for South and Eastern Europe. So I leave the stage to Antonio.
Thank you, Adriano. Let me share a few slides. Okay, then first of all, thanks also from my side to join this event. For me, it's really a pleasure to stay with you today, because for us is the occasion to show how ST is working on Mem Sensor for my side, for all the other products. And it is the occasion to highlight the continuous innovation that ST is bringing in sensors, is bringing in solutions, also in drone application. Then, but focusing immediately on the products that are relevant for drones, because I had the occasion to see all of you this morning, also with the very technical knowledge, going deep in details of technical aspect, how to use components, devices. Then about sensors, which sensors are more relevant inside drone? Then we are speaking of inertial sensors, then accelerometers, gyroscope, magnetometer, pressure. Just a few words about the utilization of these. These are used to detect direction, rotation, also altitude variation, thanks to the pressure sensor. Then the combination of this sensor is practically giving information on the movement, on the speed, on the trajectories that the drone is performing. And is also interesting how to use them to control some automatic movement of the drone itself, thanks to these sensors. Just a few words on MEM sensors, because MEM sensors for us are part of our story. We started now about 20, yes, we can say almost 20 years ago with MEMS in a continuous development. And MEMS for us are inertial, but also environmental, like pressure, but also temperature, humidity, and the microphone, MEMS microphones. But today we'll focus on inertial and pressure. What inside the MEMS? Because in this very small size, that is a few millimeters of silicon, you have a very complex, very fantastic design. Then practically you have a part that is the mechanical sensor. This one is able to detect the movement, and this movement is translated at the end in a variation of capacity. And thanks to the electronical ASIC, the electronical part that is able to translate, to analyze this signal, you have immediately the output, an output that is good to work and to be used from the drone. And in addition, inside the ASIC, you have also digital advanced capabilities. And MEMS is continuous innovation at ST. But which are the main aspects that are relevant for sensor in drones? We are speaking of accuracy, then how much you are accurate, but also how much you are stable in temperature and in time. Also relevant the low current consumption, considering the light, considering the short duration of the battery because the weight is relevant, and also at the same time small size. Then robustness, because the MEMS, as the rest of the drone, is also subjected to impact. Then mechanical robustness, very fast response, able to track all the movement with wide dynamic range, then high full scale for all the components, for the accelerometer, for the gyroscope, then are very relevant. And advanced digital features. Now ST is embedding inside the sensor that are really smart sensor, is embedded advanced digital capabilities. What do you need more? We are, I think, in the right path to support you in all this kind of development. But which are the new sensor for drones? Because this morning, some comment has been related also to previous generation. Let me highlight now the new products. New products that are representing the state of the art. Just a short introduction on accelerometer, because accelerometer is the motion sensor for excellence. Then new accelerometer are offering very high flexibility with multiple modes, with low noise, but at the same time also power saving. Then you can keep running an operative mode with hundreds of nanoamps, then less than 1 microamps. And you have digital features in a very small form factor. But more than accelerometer itself, what is really the core, really very important inside a drone in terms of inertial module is the combination of accelerometer and gyroscope. This slide is summarizing the evolution, the improvement that has been achieved in the last years. Now we have a product, consumer grade or industrial grade, offering also 10 years longevity, that are distinguishing on the market in the drones application for some specific peculiarity. Then, first of all, we have a full scale that are adequate, also in terms of gyroscope with very high full scale, and low current consumption, with the possibility to use a combo mode accelerometer and gyroscope, or accelerometer standalone with very few microamps current consumption, for instance, for wake up or other kind of utilization. But what is very relevant is the stability, the superior performance and stability. Now we have a gyro drift that is close to 3 degrees per hour. This value is practically something that is very close to the tactical military grade, just to give to you an idea how much can be stable and accurate this sensor. Then stability in temperature, stability in time, and also vibration immunity, because this is relevant. When you have a drone that is vibrating, you can avoid the drift of the offset. Digital features, we said before, advanced digital features. Practically, you can leverage on capabilities like the machine learning core, the finished state machine, that are bringing artificial intelligence inside the MEMS itself, at the edge. And you don't need to elaborate all the data going to more complex algorithm, microcontroller, or continuous connected with cloud. Also in this case, 6 axis with very small form factor. Few words also on the magnetometer. We are using AMR technology. Why? Why we are preferring the AMR technology inside the magnetometer space? Because this AMR is offering today, this magnetoresistive technology is offering the better noise. Then it means the better accuracy in the detection of the angle. At the same time, is also important the stability in temperature, because when you are flying with your drone, you are changing very quickly also the temperature. Then this much better temperature stability is really important to have valid data during the flight. Good linearity, low current consumption, and also in this case, very small form factor. Going at the pressure sensor, these are products that we have just announced about 1 month ago. These, the pressure sensor, first of all, how it is used. Then it is used to monitor the vertical escalation, but also to control, to have a safe landing. And then the estimation of the height, relative and absolute, is very important. We are able to achieve an output data rate, a frequency data rate that is very high, supporting this dynamically variation in a very fast and responsiveness way. And also in this case, we have the same common features. Then high accuracy, compact, and low power. This is our common streamline. Let me say, the innovation is moving on this path in terms of stability, in terms of low current and accuracy. Joined together with the sensor, we are also providing some software solution that we are providing for free, joining together with our sensors. We are providing, first of all, drivers for standard C, but also Android Linux spaces, and the libraries. For instance, libraries that are able to calibrate accelerometer, gyroscope, and magnetometer. All these are very important in this context. Then, not only sensor, not only hardware, but also software support. And just to say that ST is available to support the drone design with the direct support. We have also an online community and a lot of documentation. Then you can leverage on us, you can leverage on the relationship with us direct, or also with our very large documentation videos. Then you can use, and you can be sure that you have a lot of experts. Today with me, I'm presenting, but with me we have other colleagues from the product division, from our application teams, then people that are in Milan, people that are in Prague, ready and very interested, because we are in contact with you and with your activity continuously. Then thanks, and I don't know if you have already some question now, or we'll see later. Thank you.
Thank you so much, Antonio. There is a question probably I don't know if you can reply to it. If the products are not certified for in-flight safety, how and why should we use them? Then, in this kind of application, of course, I think that the question was about.
Yes. Let me say this, and I think that Adriano can also confirm. Then, what we offer are products that are robust, products that are accurate. This means that these products are ready to certify your end product. Then we are not certifying ourselves the product, the sensor itself, but we expect and we are proven to offer the quality of the product to have an end drone, an end product certified. I think that this is the result of the quality of the sensor, but also for the other components. Now we will see also for the microcontroller similar approach.
Okay, thank you, Antonio. Probably we can discuss it more during the open session at the end of the presentations. Thank you so much, Antonio. Let's move on with the next presenter. Still with the hardware components, there is Jean-Marc. Oh, okay.
Yeah. Oh, okay.
Adriano, please.
No, I leave directly to Jean-Marc to introduce himself. Sorry. I believe that.
Okay. Can you hear me? It's okay?
Yes, we can hear you.
Okay,
yes,
okay,
yes.
Good. Okay, sorry, because I have some issue with my, okay, wait a minute. The background disappear. So, you know, it's, okay, so my name is Jean-Marc Mathieu. So I'm in charge of, in the microcontroller division, I'm in charge of the motor control and digital power activities in the marketing team. So I'm very pleased to offer, I mean, to present this and to participate to this session today. So, so I'll share my my screen. And by the way, okay, I will present first the presentation with the motor control ecosystem. Then I will introduce, I will give you 2 words about the G4 series microcontrollers, and then my colleague will introduce the H7 series. Okay, thanks to the help of Frédéric Lecam, who will do this introduction on the H7 series. So now let's dive on the STM32 motor control ecosystem. Okay. So, as you know, we beside the microcontrollers, we developed, let's say, a generic ecosystem based on the cube, on the CubeMX, on different generic tools. But we have also a dedicated ecosystem like the Motor Control one. So around the STM32, we have different type of materials and I would say satellite component. And I would like to highlight here what we call the X-Cube Mc Sdk, which is the motor control software development kit. So in this development kit, you have the firmware library and a graphical user interface to configure the library at application level. Okay, so you know that with the STM32, we have the Cube and CubeMX, which are there to configure the microcontroller. I mean, to configure the things at the microcontroller level. But here we are talking about solutions to configure your application. Okay, so we are at application level. Then, okay, as we talk about the STM32, let's say that most of the microcontrollers we have in the STM32 portfolio can address the motor control application. Okay, depending on the type of the microcontrollers, you have more or less features in the product. And I will say the STM32 F3 and the G4 series are what we call our mixed signal MCU. That means this is the STM32 families which merged, let's say, rich analog peripheral set with advanced computing, and this is really helpful for motor control applications. Okay, but okay, the most important is to keep in mind that all the microcontrollers can address the motor control application, and then if we have to focus on the flagship, you have the F0 and the G0 series, which are there to address a cost-effective solution. Okay, I already talked about the F3 and the G4 series, the right balance between the analog and the performance. And on top, you have the H7 series. We already heard nice feedbacks about these very nice high performance microcontrollers from the previous presentation. Okay. So then, if we talk about, let's say, the UAV application, okay, I took this block diagram that you can find on the application tree, and I will say that, okay, you can find the STM32 on all the blocks. So, but today we'll focus on the G4 series and the H7 series. Okay, as I mentioned, the G4 with the right mix between digital and analog, and the H7 for the high performance. Okay, before we give you more detail about the different subfamilies G4 and H7, 2 words about the Motor Control SDK. So on this slide, you have the, let's say, the workflow. Let's say what you have to do and how will help you to create, to generate your code. So first you have to select, to do your hardware setup, and we encourage you to use the STMC Suite online tool, which will help you to select the board that we offer and that we develop for motor control. Okay, but then of course, based on the hardware you will have selected, you can customize this solution to fit with your own constraints. Then we have what we call the motor profiler, which will help you to detect the parameters of the motors. We know that it can be a problem to measure the parameter of the motor when you do not have the right data sheet. So we have the motor profiler, which will help you to identify, the inductance, the impedance, the back EMF, which are the most relevant parameter for the motor. So then you enter in the motor control workbench, which is the configuration tool, which will the graphical interface, which will help you to configure the library and based on your constraints, the pinout of your application, etc. Then you have you will use the Motor Pilot, which is a new tool which will help you to monitor the variables. It's a kind of digital oscilloscope, so it's really helpful for debug and for variable monitoring. Okay, with a large bandwidth to collect a lot of data when you debug the application. And then of course you have the code generation. You get the final application. Okay, this is let's say the big picture about the workflow you will use to generate and to create your application. Then about the hardware boards, okay, we have different hardware boards in this ecosystem. Okay, you have a standalone board, control board, and power board. Okay, then you have let's say a complete inverter. Okay, what we call the inverter and the complete drive. And then you have kits. So it's you have in the pack, you have the power supply, small motors, you have the power board and the control board. You have everything to evaluate the solution and to start let's say prototyping. It's also really useful for university purpose. Okay, and then based on that, we for UAV and for drone market, we encourage you to look at this discovery kit, which is part of the ecosystem, obviously, and which is supported by the Motor Control Sdk, the software development kit that I presented before. So and this board is really helpful for fast prototyping and to evaluate the solution, either the hardware solution, thanks to the different product that we use on this board, the microcontroller, the driver, the MOSFET, etc., but also the firmware solution that we offer. Okay. About the SDK, still this software development kit. Okay, we have a large set of features. I will say algorithm software features in this solution. Okay, so you have let's say this list here, and you can see on the right hand side of this slide all the different microcontrollers we support on the firmware library. Okay, and then what is new? So we have the legacy version. This is what I presented just before. Okay, and then now we are renewing completely the graphical user interface, to tackle new challenge in the near future. Okay, and we will release the 6.0 in the coming days. Okay, to to support more micros, more features, more algorithm, and to also to ease the user experience in this with this graphical user interface. Okay, so this will come soon. Okay. So then time came to talk about the microcontrollers. Okay, so let's start first with the G4, which is the okay. So the G4 in few words is based on the Cortex M4 running at 170 megahertz. And as I said before, we have a lot of analog in this product to address different type of application. So and mainly digital power and motor control application. So 5 ADC, 7 comparators, 7 DAC, and most of the these analog peripherals were designed to address the application I mentioned before. Okay, it's not they are not, let's say, generic analog. It's I will say it's a rich advanced analog peripheral set we have on the G4 series. Then we have obviously dedicated motor control and high resolution timer. Okay. To address again the motor control and digital power application. Okay, robustness is enhanced. We have also the security with different set of features in the microcontroller that you can select. The functional safety pack and the FD-CAN. When I refer to some previous presentation, I know that there are some there is a trend on the CAN FD. So this is we have up to 3 instances of CAN in the STM32 superset product. Okay, and then here the different, I would say, sub series. I mean, different lines we have on the G4 series. I will say the general purpose motor control, and on the other side we have the digital power product lines. And if we look at the different, I mean the major peripheral we have on the product lines, on the G4 product lines, you know, the high resolution, the performance, the access lines. Okay, you can see. Okay, the main difference is the the presence of the high resolution timer on the G474. Okay, for high resolution, but this is mainly for digital power. And then we have, let's say, the level of analog, which is different between the performance and the access line. Okay, this is the main difference between and then, of course, when I talk about the level of analog, that means the number of motor that you can control with the product. Okay, you have up to 3 motor control timer in the big, I would say, in the superset, down to 2 motor control timers with different level of analog. Okay, and then just one remark about the let's say what is new, what we introduced in the with the STM32 G4 is the new mathematical accelerator, which will help you to speed up the execution of some functions, mainly DSP functions, but also to offload the CPU, because while these accelerators are let's say executing these operation, the CPU are free to do something else. So we accelerate and we offload the CPU at the same time. Okay, so it could be really helpful for motor control and digital power. And okay, and then talking about, let's say, the nice set of peripherals that you have on the G4. Okay, again, we couple the high computation thanks to the Cortex M4 running at 170 megahertz, plus the different hardware accelerator I mentioned before. Okay, with the timers and the analog and the nice level of analog we have on the on this product. So then I'm done with the G4 and the motor control ecosystem. Is there any question there, or before we move to the H7, the high performance microcontrollers? Don't know if
yes, you received a lot of questions during your presentation. First of all, there is Andrew Trigel, the former presenter that we had before, that is asking a lot of questions for you. But I think that we can move with the next presentation and leave space to the open discussion after the 3 presentation, because we are late.
Okay.
I hope that you will remain here and give the possibility to the attendee to speak with you and ask more questions. Thank you so much.
Okay. So Fred,
yes,
the floor is yours.
Yes, thank you very much. I hope you can hear me well. Okay, so I'm Fred Lecam. I work in the same team as Jean-Marc, but I'm in charge of a different product line. So I'm in charge of the STM32H7 product. So just a quick reminder, and I will try to go quick because I understand that we are running a little bit out of time. So the STM32H7 is part of the high-performance STM32 portfolio, as you've seen at the beginning, the presentation of Jean-Marc, and this is very focusing on the computation capability. So we have a device that is running up to 550 megahertz in some versions, and some other versions are going up to 480 megahertz. Also, for your knowledge, we have also some dual-core devices combining the M7 and the M4 on the same chip. Security is part of the feature that we offer on this device, and also many very large number of peripherals. As mentioned by Jean-Marc, ecosystem is also part of the offering and is very important to enable this product series. Thank you, Jean-Marc. You can maybe, thank you very much. So this is an example of a block diagram, of an application block diagram that we can implement with the STM32H7. So here you see that we have the Cortex M7 core, which is basically dealing with external memory interface when the internal RAM or internal flash is not enough. And it is also dealing, for example, with display in case you would like to implement some graphic application or some other computation, like you want to do computation, DSP computation, for example, for some specific applications such as a drone. As I mentioned already, so we have a flash on board up to 2 megabytes. I took note of the remark of Andrew at the beginning that the sectors are quite large, which is true. We have also some version of the H7, which is offering 8 KB of sectors. So this is also on the part, smaller part of the portfolio. Beside the flash, we have obviously the RAM. So the RAM is up to 1 megabyte. It is scattered in a different portion inside the device in order to serve different type of process. Acceleration, we have a Chromat accelerator, which is for graphic, probably not very useful for drone application, but JPEG codec also to encode and decode some image. Security is also part of the chip, as I mentioned, and obviously on the other side of the chip, we have the Cortex M4. The Cortex M4 is very much oriented on the real-time kind of application. So it can, for example, deal with Motor, like already highlighted by Jean-Marc. It can also connect to sensors. It can also run some communication through specific stacks, for example. And I put also an example of an advanced peripheral that we have on the chip, which is named the high resolution timer. Yeah, next slide, please. Who is having the hand on? Yeah, okay, thank you. Yeah, and the second, there is a second block diagram, which is basically a different version. It's more focusing on the high resolution timer, which is a timer dedicated to generate complex and advanced, very advanced waveform. So this is a very sophisticated timers that comes with different channels. Okay, next slide. Thank you. Here is the portfolio of the STM32H7. So as I mentioned, we have different kind of subline, let's say. So we have on the higher end, we have the dual core line, which is composed of 2 different lines that are coming with the Cortex M7 plus the Cortex M4 on the chip. We have then what we can call a single core line, where basically only the Cortex M7 is exhibited in the chip, and we have different variants of the single core line. And I guess most of you are quite familiar with the H742, H743, and so on. But I want just to mention that the one on the left, which is the STM32H7A, is the one, so this is a device that is able to run up to 280 megahertz. And on this device specifically, we have a larger RAM. So we have a 1.4 megabyte of RAM, and it also comes with the small flash sectors that I was mentioning at the beginning, down to 8 KB of flash sector. We have, in addition, a value line. So this value line is at the bottom of the slide, and it is spread over different kind of variant. Next slide, Jean-Marc. Thank you. So here is a summary of the product portfolio. So this is probably quite small. I'm not sure that you can really read everything in detail, but this is to give you a bit of the features that we can find on the chip. So as I mentioned, single and dual core performance is mentioned again, 480 megahertz maximum frequency, up to 1.4 megabyte of RAM with the device I just highlighted a minute ago. Security features are listed here. We have also on some devices the capability to make on-the-fly decryption when reading the code from external memories. We have a very large communication peripheral set composed of Ethernet, CAN, many SPI, I2C, UART, so many synchronous and asynchronous communication interface. We have an advanced 16-bit ADC able to go up to 3.6 megasamples per second. And we have also some 12-bit version able to run up to 5 megasamples per second. On some devices, we have also some comparators embedded and op-amp. Obviously, this H7 is not comparable to the G4 that we just mentioned before, because we don't have these advanced analog features that you will find on this other series. But here we have a pretty good subset of analog features already for a general purpose MCU. FD-CAN is also part of the offering. High resolution timer, I already mentioned, some low power timers, and you have also the possibility to supply the chip either LDO or SMPS if, for example, the power consumption is an important criteria in the application, which probably is not so much the case on the drones, but so just you know. On some devices, we are also offering the extended temperature range up to 140 degrees C junction temperature, which correspond to a maximum ambient of 125. Those are options, so which means that if you want to order devices able to run a high temperature, you need to order a specific part number in that case. So that's pretty much what I wanted to tell. So very quick, probably too fast. Sorry for that, but I just wanted to cope with the short time that I had now. Thank you very much.
Thank you so much too. Adriano.
Yes.
Are you connected?
I will okay. Recover the times. So only to say that I was also happy that someone previously presented an part of the drone focus, like the battery management system by Ramon, that is also part of our portfolio. And also there, the STM32G4 that has been presented by Jean-Marc could be used and could address this part of the drone. Only since I would also close the fact that we presented mainly the microcontroller G4 and H7, but I would also remark that we have also a microprocessor line that could be used as a supervisor of the flight controller unit, or in general to do more high level task. So also in this case, we had not time to go in deep on it. final message by me, and is on the disclaimer. I seen the question on the chat about it. Let's consider that when we talk about aviation, we are not talking about we are talking about a system that fly at 40,000 feet. So generally is not the altitude that we consider for a drone design. So let's only specify these that could be important to separate what is avionics, aeronautics, and in terms of altitude respect to normally what we consider in this market. That's all also from my side. I hope that the people consider that the wide portfolio of ST, and I leave to you to manage the question and answer session.
Thank you so much, Adriano. We have still few minutes, but we received so many questions that needs to be replied. So in this moment, because all the presentations are finished, we can start with the open technical question and answer session, where all the participants can ask questions, raising their hands using the Microsoft Teams platform, or if they need it, they can write, and I will read the question in the chat. Well, let's start from the last question that we received for Jean-Marc. One question comes from Alexandre Bustico. Does tools, I think that this was referred to the SDK, to generate source files that are usable in open source project, or does we should link a binary blob to make firmware?
I was on mute. No, it's a source code, and then you can use it till you use the SM32. There is no problem for you to. It will be your own source code. And by the way, it's you know let's say the Motor Control firmware library is given for free and in full source code on the web. So everything is open. Open, and you can do what you want. Okay, you just have when you develop the solution, you just have to pay attention that you have to keep the license agreement in the header of the files. That's it.
Okay.
It's really the purpose of this solution.
Okay, there are so many questions from Andrew. Please, Adriano,
Salvatore, yes, I would add that the same is valid also for the sensor part. Clearly, as underlined by Jean-Marc, our software license agreement that we provide the source code free for the customer, the software has to be used with ST product. This is the only request that we do to you.
Clear. There are so many questions from Andrew that I would like him to join this conversation. Andrew, could you turn on your camera and ask the question that you proposed in the chat directly to the presenters? I can see him disappearing. It appears, you appear and then disappear again. Andrew, let's wait for him to join. I see you connected, but you should turn on your microphone, Andrew. And if you can, also the camera to ask a question directly to the presenters, or.
Got it. Okay, great. Sorry, somebody had muted me. Is that better?
Okay.
Is that working?
Yeah. Now it's working.
Yep, great. Sorry about that. So fantastic presentations. Thank you so much. And I really love that we can talk directly to the people involved in these products. On the G4, we really like the G4. We're focusing on the G4 for peripherals, for airspeed sensors, GPS, communication boards, that sort of thing. We're moving to CAN FD, and we haven't managed to get a stable CAN FD 5 megabit or 8 megabit between the G4 and the H7. So the main flight controller at H7 and then a peripherals. H7 to H7 works great. Is it expected to work? Is there any sort of gotcha there that, you know, or is it just that we've got the wrong timing?
If I'm not wrong, okay, so Frederic, I think you are there as well. On the CAN FD, okay, we have CAN FD on the G4, but you have also CAN, which are not I mean the specification of the CAN peripheral are not the same between the H7 and the G4. You know, mainly related to the buffer size. Yeah. So again, I'm not the expert of the CAN. I can take the question and come back to you, but I know that the two peripherals are different between the H7 and the G4.
We've written driver for both, and they both can talk individually. We just need to. I mean, vendors will ship like an H7 in like that, and then they'd ship the G4 is cheaper, smaller microcontroller, so it's great for peripherals like this, a GPS or a airspeed sensor like that, smaller device, but it's no good if they can't talk to each other. So we just would like to get confirmation that 5 megabit and 8 megabit with bit rate selection, 1 megabit framing, which is the standard that we're using in DroneCAN. We'd just like to know that, you know, we should keep trying and it can work, or if there's some reason why it can't work, we'll have to change the standard perhaps.
So I take the question. I don't know if Fred, you know, you can answer, but I will take the question on my side, and I can come back to you, and we'll come back to you to give you the right answer. But Fred, if you have the answer,
for sure I don't have the answer, but there are two aspects. So what you mentioned, Jean-Marc, is about the size of the mailbox, which are different, different implementation between these two MCUs, but it is no link with what Andrew is mentioning, which is more linked to a speed in this case. And from that perspective, I would guess that FD-CAN is a standard. Is just a standard. The devices are compliant to the standard because the CAN cells are compliant. So there should be no issue regarding whatsoever regarding the speed that you're gonna use to speak between the two chips. So in principle, I would say no, but yeah, as Jean-Marc says, we take the question and we will verify on that again.
Thank you.
And Andrew, did you receive also interesting feedback about the new sensor? Please let us know.
Yes, I thought that was the very low drift rate. You were talking about 3-4 degrees per hour gyro drift rate. That looks very interesting. However, we've been burnt in the past. How is that measured? When often we get from a vendor a claim of an extraordinarily good drift rate, but what they're doing is the measurement of that is done against a hanging in free space by wires rather than actually on a PCB. And the interaction between the sensor and the expansion of the PCB can be quite critical. And we find that once the device is actually bonded on a real PCB and used in the real world, the performance is not nearly as good, and that happens for both barometers and IMUs. So when you provide those measurements, in what circumstances are you testing that?
Yes, then these are based practically on Allen variance measurement. Then this is done on parts that are also soldered on PCB, multiple parts. Then we are testing with the standard method. Then the method that we apply is the Allen variance measurement, and this is the result done on multiple parts.
All right. So on IMUs, I mean, I could sort of talk about IMUs all night.
But we can share also data with you.
Yeah, that would be appreciated. The other thing that we've often noticed in IMUs is vendors don't provide the full signal chain. We need to know exactly at what the sample rate is at the ADC, all of the internal processing stages. So, for example, Analog Devices provides their signal chain in their data sheets, but other vendors like even InvenSense and Bosch and things don't provide the full signal chain, which means we can't design our notch filters and our filter chain appropriately without that sort of data. Do you provide or can you provide the full signal chain from inside the sensor?
Let me say this is protected usually by NDA because our information, confidential information that we don't share in the datasheet, but we can explain and we can show to you how it is possible, for instance, to configure the different filters that are inside the sensor to achieve the best utilization of the sensor itself, because you have the flexibility between different output data rate, different configuration of high pass, low pass, and other kind of filters on accelerometer and gyroscope, also independent.
The focus for a lot of us in choosing sensors is defeating aliasing, because a lot of vehicles have high frequency vibration. And the benchmark these days is the ICM4 series from TDK and InvenSense, which have 32 kilosamples a second at the ADC. And that is absolutely fantastic for preventing aliasing issues on the accelerometers. What sort of sample rates do you have happening at the ADC?
The maximum that we have is 6.6. We have also the possibility to go around the 3.3 and other less. Then you have the flexibility to configure the different filters at different output data rate, also dynamically. Then you can also change dynamically this.
It's not the output data rate that matters. It's the internal sample rate inside the sensor.
And the relative filters, yes. We have different filters associated at different output data rate. But more of this information are already in the application note. If something is not yet public, we can share with you.
That would be appreciated. Yeah, we don't build the boards ourselves, but we provide feedback to all of the vendors who do build the boards and advice on which sensor to choose. We had a bad experience, as I mentioned earlier, with past ST sensors. So we'd need to sort of get some real detail to look. Mentioned the other problem that we've often had is that if you look at the data sheet and they have columns for minimum, maximum, and typical, and most of the vendors only fill in the typical column. They don't fill in the minimum and maximum. And so you really don't know what range or, a value for temperature drift, what the actual, range of values will be on real sensors. Some vendors do fill in minimum, maximum, typical. Just a feedback, it's very useful to have that range.
Yes, usually the typical is indicating the sigma of a Gaussian distribution. Then you can consider 3 sigma to reach the large number, about 98, 99% of the distribution of the population to move from the typical to the maximum. We are also distinguishing between consumer product, industrial, and automotive. Then when we go also to industrial and automotive, we go to guarantee also the min max. Then in other cases that's guaranteed by design.
Okay. Yeah. Well, as long as they're software compatible, that's fine. As long as the industrial, then we can get our higher end vendors to use the industrial ones. That works fine.
Yes.
Thank you.
Thanks to you. Thank you.
Thank you to both of us, both of you. This is the kind of questions that we would like to have always. We received many other questions in the chat. There is Lucas Fischer that appreciates Euro pumps in the STM32G4, and he asks a question. He says the power is there for sensorless FOC. I think it is working on motor control. Will there be a workaround for this? This is the question. If Lucas is here and would like to directly ask the question, he can raise the hand and we will give him.
I don't really understand the question because I'm reading the
question. There is Lucas
here.
Yes. Lucas?
Lucas is there.
Yeah. Lucas, we can.
Yeah, you hear me?
Yeah, we can hear you. We can also see you.
Okay, yeah. Here's Lucas, and I'm currently working with the SDM G4. So it's a really cool product. I like it, and I'm currently trying to implement sensorless FRC. So because we have here our vehicle and it's the motor is directly in the tire, and we want to skip the sensor. And I know this is possible from some random YouTube videos, and I want to know if there's some work around this to skip the sensor and just using current sensing. And I think with the SDM G4, it's possible because of the op amp integrated into the chip. Yeah, is there? I mean, it's also because I have the drone development kit. I think it's the I don't know, B. Yeah, I don't know. It's the drone development kit, and this kit has also current sensing on the PCB. And yeah, I just want to know if this is possible, or if there is. I know it's possible, but if there is work around this.
So yeah, no problem. So yeah, there are two questions about the open, but also about the sensorless solution. So we have a sensorless solution in the motor control ecosystem, as I mentioned before. We have the SDK do you use the motor control SDK? The ecosystem from ST?
No, because I find it rather difficult because we are just using Linux software, so we are not working with that. But we are using the how it's called, the simple FRC from Arduino. So yeah, we are using that because we are trying to. We don't have Windows machines here to test it, but we will soon. I just tried. Yeah, I'm just starting to develop this.
Okay, but so in that case, I would suggest that you use a pack. The pack I present before. I will show it again. This is the okay. This is sorry. I will show that on the presentation. I know I shared before. We have different kind of hardware. And this is the P-Nucleo IHM03. Okay, so this is definitely let's say the best solution to evaluate the solution, and also to use to start to use the library, the motor control library we have. And of course, in this motor control library, you have the sensor, but also the sensorless solution, using or not the analog we have on the product. So for me, that the best would be for you to use this this pack to start to dive in the STM32 motor control dedicated ecosystem. Then okay, I don't know if you know that we have. If you are lost because in ST we have let's say a large portfolio, and we so let me show you if it is. So again, in the ecosystem, this is the SDK. This is the motor control SDK that I just explained, where you have the library and the graphical user interface. We have a dedicated web page. Okay, if you need to get data, to get material related to the motor control, but based on the STM32, I encourage you to go on this web page. So let me tell you what is I can give you in the chat the URL of this web page, because I don't put it in this in these slides. So I will put the URL of this motor control web page on the chat. So then based on that, you will have access to all the links to the different material, hardware, software, and the different things. But again, to evaluate the solution, the best is to start with this Pinucleo IHM03, and based on that, you will be able to operate the different algorithm. Sensorless is one of them.
Yeah, I already have the BG431B, the drone development kit. So okay. I have this one. Yeah.
Oh, you have this one. Okay, that's perfect. That's perfect. Yeah. Then okay, on this one, if I'm not wrong, you can you have this. So then you can operate censored or sensorless. You have the solution. So the question will be about the op-amp. I think we have the possibility to turn on or turn off the op-amp, the internal op-amp. I mean, to use external op-amp or internal op-amp. If you have any questions, contact me again. So, what is your? I don't know if I reply to your question. If it's clear for you, it's clear or not?
Lucas? I think that Lucas disappeared. Yes.
Yeah.
Anyway, thank you for your reply. Yes, there is a question from Pierre that is raising your hand to Andrew. They were discussing in the chat, but I think that this discussion can be useful also for other people that are listening today. Pierre.
Yes, hello, good afternoon.
Pierre, thank you.
Can you hear me?
Yeah, we can. Yeah.
Good. Yeah, well, the reason I joined this conversation is because I've been developing this new concept of flying object, and I've faced some difficulties to enter into the community in a way on both the software and the hardware. I've been very interested to follow the work that has been done on Paparazzi. Actually met with the people there in ENAC, and also I had some contact with Andrew earlier from Autopilot. If you allow me, I'll just spend 1 minute. I will show you the concept, so you can maybe share that. It will be more easier for me. So let me try to. I'm not sure if I can. Can I share my screen or?
Yes, you can, if there is.
No, it doesn't seem to be working now.
You should be able to do so.
Okay. Well, in any event, so my question really is when you come with a new vehicle, what is the best entry point? Is that through the software that will guide you through adaptability to their open source, and then guide you through, obviously, the hardware based on your requirements? Or should I start with really my requirement in terms of PCB or microcontroller, and then try to learn from that and build my hardware? I actually purchased a Nucleo 32 L4, which I'm going to try now. But unfortunately, until now, I had to do it all over again on Autopilot, and that's quite harsh for me. So any guidance there would be very helpful.
So I could answer that briefly there. I get a lot of people approaching me about new vehicle designs, and it's fantastic working with them and bringing their design to reality. Usually the point to start isn't on the hardware design of the electronics. Usually the concept should be tested first in simulation. And so we commonly work with, the individual who's got the idea and try to build up a simulator. And so we support a whole lot of different simulation frameworks. Different ones are appropriate for different projects. So a recent one I've done with NOAA, for example, which might be relevant to your work, where we were working with the US NOAA agency, dropping gliders from 75,000 feet And that was part of the extreme Autopilot project, where we needed to develop solutions for very high altitude flight. And we've worked with other people on very long endurance so that Autopilot can run for, you know, over very long distances, and these estimation algorithms can support going right the way around the planet without becoming unstable, because there's issues with, you know, certain types of mappings of latitude and longitude and the sphere of the Earth. There can be issues with that. There can also be issues with running for a very long period of time. So I started a sub-project within Autopilot I call Extreme Autopilot, which is really just a series of patches to address each of these issues: very high altitude, very long distance, very long endurance. I don't know your particular vehicle. You mentioned it's a hybrid rotorcraft fixed wing. We have flown multiple hybrid rotorcraft fixed wing. You could look, for example, at the stop rotor. I'll just put in the link to it. So that is a stoprotor.com.au. That is a hybrid helicopter fixed wing. And we have, of course, quad planes, numerous types of quad planes, which are hybrid multi-copter fixed wing, but you can also have hybrid helicopter fixed wing. And there are many variants. There's a new variant of these hybrid VTOL aircraft that comes out each week. And the first thing we tend to do is build a simulator to test the concept, to make sure that the fundamental aerodynamics and the control algorithms will work. And that saves you a lot of time before you get down with the hardware and a Nucleo board and your sensors, because that side of it is usually actually the easy side.
Yeah, actually, Andrew, I did. I mean, the last 8 years has been in developing MATLAB models. So I have all these models. Mm-hmm. And the model actually,
well, we can fly MATLAB models. You can actually take Autopilot, connect it to MATLAB, and Autopilot can fly a MATLAB model. So if you've got a 6DOF model in MATLAB, you can connect it up and fly it in, you know, as fast as MATLAB can run it. And as long as your model has high fidelity, then you'll be able to tell whether Autopilot can fly that vehicle.
Okay. Well, if you allow me, I'll contact you through LinkedIn, and we have a little
look forward to it.
Maybe one day I'll show you, you know.
Yeah. I'm sure Paparazzi can do all this too as well. If you're in France, I'm guessing from your accent, you might be in that part of the world. Paparazzi, I'm sure, could do this sort of thing as well if you prefer to work with them.
No, I'm in Dubai actually. So I'm
okay, all right, no worries.
Thank you, Andrew.
Thank you, Pierre. Thank you, Andrew. Adriano, probably the question that made Andrew is for you. What is the best method to contact ST speaker after the event? Andrew, hi.
I believe that clearly you can write to me or directly to the separate person. Here I ask to Jean-Marc and Antonio and Frederick what they prefer, or I have to.
Could you perhaps, when you publish the slides or the video, you give some email address contacts for the speakers, particularly the ST speakers? I'd be happy for my emailers also to be given out if anyone wants it. Or, you know, LinkedIn links or whatever is most appropriate, you know, for the speaker, just for follow-up questions. That would be great to know how to get in touch.
Yeah.
Or you know, maybe we should have something on the ST forums, like a UAV section on the ST forums. For,
yeah, we have it.
You know, there is a UAV section there already, or?
Yes, there is a drone section with. Yeah, there is a drone section within community. And clearly, you can contact also our people in the region, depend on your latitude. So we have a lot of field application engineer around the world that could support you on the different topic.
Just trying to find the drone section of the community now. I hadn't realized it was there.
I'm going to share the link in the chat.
Thank you very much.
we received many appreciation for all the attendees. In any case, I think that everyone can read the
I really appreciate the effort you've put in today to have such a good lineup of speakers. It's been greatly appreciated.
If there is anybody that has got a question to ask to the presenters, somebody had to leave because of the time zone, of course. But if you would like to ask any question, please raise your hand using the reaction on Team, and we will give you the possibility to ask a question. They suggest me. USA contacts. Okay, they want. I think that the answer is the same. Try to contact on the forum, Adriano.
Surely they could start on the drone zone community, and starting from it, clearly the people could be followed also in. We have a lot of contact in US, so it's depending on the single question that arrive, and depend on what is the dedicated topic.
Here we have Giovanni Di Sirio that raised his hand. I think that he would like to add something. Giovanni.
Yes, a question for Andrew. Andrew, you mentioned the problems with the Liberty license. My question is, which specific aspect makes it not compatible with open source licenses?
Oh, sure. So let me just bring up that license now so I can get the paragraph number. So just give me a second. And if you have a look at paragraph 5, it says no use, reproduction or redistribution of this software may be done in any manner that would subject this software to any open source terms. Open source terms shall mean any open source license which requires as part of the distribution the software be distributed, made available. And it specifically mentions GNU General Public License, BSD license, MIT license, Eclipse Public License, and Apache Software License without restrictions. So that's the paragraph there that I've put in the chat. And that essentially, I mean, that's incompatible with your own licenses. It means you can't distribute any of this code onto this license with, for example, your motor driver license, which is BSD 3 clause, because that would combine it with the BSD license, which is specifically excluded by your own license. So you're not just incompatible with the rest of the world, you're incompatible with yourselves. It's one of the most ridiculous licenses I've ever seen. You know, it really is quite awful. There's a lot of, we specifically avoid all ST code that has any of these types. This isn't the only license you've got that has these types of terms. You've got some other variants of this that are obviously evolved over the years. It's also rather problematic that you link, when you put on a piece of code, you give a URL for the license, and the content of the license varies. So it's not a stable license. So, you know, you look at a different year and you find the wording has changed, but it's linked from a piece of code. So I think you've got some work to do on you know, making sure that you don't have these types of odd licenses. And there's organizations that could help you with this. You know, Software Freedom Conservancy, Software Freedom Law Center, those types of groups could help you understand open source licensing. I'm not a legal expert. I used to teach a course in open source licensing, but I did it as a non-lawyer. But you certainly could raise your game there and make those licenses a bit more, you know, widely acceptable.
Thank you, Andrew.
You're welcome.
Thank you both. Thank you, Giovanni, and also Andrew for the reply. In any case, we still have 10 minutes. There is no any other question in the chat. Thanks. I don't think so. If anybody would like to add something, I see people going away. I think that now it's time to. We started with more than 100 participants. Now, more or less, it halved. It was interesting. Thank you. Okay. Thank you so much. Thank you to everyone that attended this event. I would like to call Alan if it is connected, because it's the main promoter of this kind of events. Alan, are you connected? Would you like to add something? Alan Smith.
Yeah, hi, Salvatore, and I'd like to thank all the presenters who presented today. This is really an open innovation event, especially Giovanni, the idea to start this event. I think it's been great. The open source community projects have got to know some of the people in ST who can answer directly your questions. So I suggest the leaders of these communities contact directly the people they've met today, in addition to where Adriano recommended. And I think it's good to have made the contact. So I like to thank everybody for the participation, and it's been it's been a good technical discussion, frank technical discussion to try and resolve some issues, make things clearer. And I don't know, I think we should make another appointment, maybe in 1 year, apart from the follow-up everybody does, maybe in 1 year, to move ahead. What's everybody's opinion on this?
That's Alan, this is a good point. I think that this event has been appreciated so much from the audience, because we received many questions, and also they congratulate about the presentation. Also the possibility that of both two worlds, we have the ST world and the open source community world that had the possibility to interact each other today. And as we see, Andrew, Adriano had a lot of discussions today, and there is from both sides something to think on, and give the possibility to them to go ahead and develop many other things with the new hardware, new technology, and also for the ST, new projects to work on. Adriano?
Yes, we can, thanks to Alan and thanks to you, Salvatore, we can organize a further meeting next year. We clearly we can hope. I see that there is some request about the time zone compatibility respect to North America. Yes, we will rearrange it maybe in order to take more people also from US, and I agree on that. And in fact, I'm sorry that Ramon left us due to time shift between Europe and the US. Next time we will reorganize different.
Of course, this event came from it's managed in Italy, so probably it's more comfortable for us to have this time zone, but we can manage to have a different time zone. In any case, like we said at the beginning and during the session, the event has been recorded and will be available online. So if anybody would like to see it again or left something behind because it was late or for any other reason, he can join, he can see it later.
Yeah, and let's thank again all our distinguished speakers. Okay, I mean, we didn't really introduce them with all their bios, but I recommend you go and read the bios of our distinguished speakers, starting with Giovanni Di Sirio, Professor Domenico Accardo. Great presentation. It was good hearing from Andrew. A big privilege. Go and read his bio. Gautier Hattenberger from Paparazzi, and I know there's also Alexandra from Paparazzi, but we didn't see him directly. Okay, Bob with the fantastic Pecan balloon project, so interesting. And of course Ramon, who had to leave from Drone Codes, and I think we were covering the whole world in terms of time zones in this. And then thanks to the ST speakers. Okay, so now you know them, and Adriano, Antonio, John Mark, and also Sebastian, particularly for the H7. The ST emails, for if you know the name and last name of an ST person, that's what the email normally is, name, last name @st.com. So Thanks all. And I have a question. I'll ask the question to Adriano. What about this point of the software license? This point which was brought up. Can you follow up on that, Adriano? It seems like a difficult point.
On the software, maybe I missed this part in the chat, but I seen something by Andrew, and I understood that with Giovanni. I will check. Clearly, if I understood correctly, there is a reason behind the fact that we have different software license for any software. And let's consider that we are many times the software license agreement are written around the single product that are made with. So clearly the software license agreement of a microcontroller software is different respect to the software license agreement that we made for a sensor or we made for a motor control device and so on. Because anytime we try to protect one part of the ST portfolio. So we can go in details, but I don't know if I will find a final answer. This to be really frank with all of you.
Consider that a software license is something that can prevent the use of our products. So it is very concerning for me.
I think the underlying issue is, I suspect that a lawyer in ST was trying to prevent your sample code being used on non-ST microcontrollers, because there are microcontrollers made by other companies that are almost ST compatible. They're annoying to work with, I find, but you know, they're sort of compatible enough that maybe some of your example code could work. And you've put an enormous effort into your libraries of headers, and you don't want that effort that you've put in to then benefit other manufacturers. And I can very much understand that motivation. It comes through very clearly in the wording of those particular licenses, not the ones that are under BSD 3 clause, they're great, but the ones that have these odd ST licenses that I pointed out one example of. And I can understand the motivation, but you need to also understand that these open source projects like Paparazzi's been around since, you know, the big invention of the computer, I think almost. You know, the Autopilot project, the Betaflight Px4, they've all been around for a long time, and we have established licenses. We can't change our license, and our licenses, you're specifically mentioning you cannot work with each of the licenses that these open source projects use. So it's while I can understand the motivation, it does damage in terms of the ability to share. And of course we work around it. We just don't use those libraries, don't use those headers, but it creates friction. And so if you can lower that friction to make it easier to use some of these pieces of you know, libraries that you've developed, that would be appreciated. It's not going to revolutionize things immediately, because, you know, we've got things like Shibios that Giovanni makes that has fantastic license, and it replaces, you know, those components. But it's still, I think it would be a good move, you know, to try to make sure that all of the open code you release is under an open license that is compatible with widely used licenses in the industry.
Mm-hmm. Yeah, we will analyze it. I hope that we will do our best.
It's tricky.
It's tricky, yes. Yeah. Because sometimes, let's say that also counter us. Clearly, some product division will blind not the microcontroller but their product and so on. And clearly, any time that we generate a new product and a new software, clearly there could be an update of the license, and not always we take care of the previous software that has been published, for example, a couple of years ago and so on. So this is also another issue that we have to maintain. But thanks for this feedback. I will try to take care.
How this actually affected us directly. We got a contribution, a very nice contribution to Autopilot some years ago, and it used a Git submodule, which had another Git submodule, and eventually that submodule chain used some code with this ST license. and that contaminated all of Autopilot. And we had to do a whole removing tens of thousands of lines of code and do a new release to ensure that we weren't in violation of your license. And it caused us quite a lot of pain. We had to remove initially support for a class of boards, and this was some years ago, but it was actually quite a painful process once we discovered this. It was like a license contamination that happened deep in a submodule, and it made things quite tricky.
Yeah, I will check with our legal department.
Thank you.
Thank you to you for your feedback.
Thanks to everybody. Hi, Alan.
Yeah, so thanks everybody. There's been lots of people in the background of this event, especially with the various open source projects. I see Alexander Bustico is there. Alexander, do you have a specific comment? Can we see you in the video with a comment from Paparazzi on this event?
No, it was a fantastic event, and we learned a lot, and we're happy to have some contact in ST. So I think we will continue to discuss and to have some information to solve some particular points. So I think it's a good start. And thanks for Giovanni to make this happen.
Thank you. Thank you, Giovanni. A final word.
Okay, you want the final words from me? Okay, thank you everybody for attending this meeting. I have been pushing inside and outside ST to make this happen, and I think it has been a success. If we can improve our processes internally in ST and also make the open source communities more willing to work with us, it is better for everybody, I think.
Thank you, Giovanni, for these concluding words. I see that many attendees are leaving this meeting. We have a few participants left. I think that now we can say that the event is concluded. And thanks to all the participants, thanks to all the presenters. Thank you, Adriano, that I can see you. Thank you, Frederic. Thank you, Jean-Marc. Of course, thank you, Giovanni. We have to thank also all ST Microelectronics for supporting this kind of events and give us the possibility to have these moments, educational moments. Alan.
Wonderful. And as a final word, thank you to our moderator, Salvatore from the University of Salerno, postdoc in industrial control engineering. So thank you, Salvatore, and all the people behind the scenes in ST who have organized this event. Okay, bye everybody. Thank you.
Goodbye.
Thank you. Bye-bye. Bye-bye.